Hey, welcome everybody. We have got Mr. King Crocoduck with us today. We're going to be trying to get through a little bit about the Bell inequality, maybe touch on pilot wave theory and superpositioning. It's a complex topic, and I'm no pun intended there. Few people get that joke, but it's something that a lot of people have been asking about. They wanted to learn more about quantum, and quantum is not one of those things that you just kind of go into. It's something you have to take a lot of time to actually want to learn. Something that I never did. I took a lot of physics courses relating to nuclear stuff, and I had to learn things relating to waves. So I did understand what a superposition is classically, and I do understand how to describe the state of the system classically. But quantum is a whole next level thing. And so I was hoping kind of Casey, since this is an area that he's quite familiar with, or at least more familiar than anybody here, can kind of suss some of these things out, some of the questions of what actually it is meaning to have a superposition. What is the Bell inequality, and why is it so important that if you have a theory that it satisfies the Bell inequality? There are some theories out there, people have been mentioning it before, about pilot wave, where it does meet the criteria for Bell inequality, but at the expense of giving up locality. And so we're going to talk about what locality is. We're going to talk about what realism is. And I've invited a lot of people. Some people say they can't get in. I don't know why. The link is out there. I put it in the live chat. If it's not working in the live chat, message me directly. For some reason, it's not working in the live chat very well. I had this problem yesterday. So I will get the link here. I have it ready at the go. Just message me, Shannon, Average Joe. You're a nuclear engineer. Come on in, Barney. You're good at this stuff. So come on in, and we'll just kind of dive into it and see what kind of happens. So, anyways, Casey, welcome back, man. It's been a while, dude. I miss having you around. I know you've been doing a lot with your vlogs, and I do kind of try to watch them, but honestly, the political stuff goes way over my head.
Glad to be back. I don't believe I've been here since the Hovind Wars.
Yeah, no, you haven't. So basically, you got scared off because of Hovind. No, just kidding. You did a masterful job on that. That still is one of my favorite things of all time, because that takedown was just epic. People are still talking about that today, because I don't know if you've noticed, but have you noticed Hovind kind of dropped down his rhetoric a little bit since then?
Maybe. I don't know. I haven't been watching his stuff.
Much as we do. I think he has. He doesn't. He doesn't really want to go on to other people's channels any longer. I think he knows he had his ass handed to him, not just by you, but by Bill Ludlow and other people, that his shtick doesn't work as well as it used to, right? Because there's so much information, people go out and look and say, oh, look, Hovind's saying this, but I got a refutation for that now because I understand what the topic is. 10 years ago, it flew a lot more easier because nobody knew what the hell he was talking about. He just sounded like he knew what he was doing, right?
Yes, and now Hovind, as with most incompetent generals, is trying to fight the previous war.
He really is. Yeah, that's a good, excellent way of putting it. He seems to be. I don't think he's realized that the war is over. I mean, he's tilting at windmills like Don Quixote at this point. So, but anyways, let's dive into this a little bit. Can you give us kind of a brief synopsis of what you think the Bell inequality? If you have to like explain to people a little bit about wave functions a little bit, by all means, and then we can kind of screen share as we go along if you need to like show a specific formula or a relationship or something.
Sure, I think that best way to approach this is by starting out with some properties of classical waves, moving on to matter waves, explaining that as a probability wave, saying what implications this has in terms of uncertainty principle, and then from there, jumping into this paradox that lies at the heart of quantum philosophy.
That sounds just as good as any place to start, I guess.
All right. Well, starting with the classical conception of waves, a physical wave, whether it's a sound wave or a wave on a spring, um, this is a disturbance that's passing through a particular medium. Energy is moving from one end of the medium to the other, and it's doing so according to some sinusoidal function. Um, and there are various properties associated with this. You have the height of the wave, which is the amplitude. You have the how quickly peaks and troughs are passing through a given point at per unit time. That's the frequency. You have the inverse of that, which is the length of the peaks and troughs away from one another. So peak to peak or trough to trough, that's your wavelength. And you have all of these various properties that allow you to understand sort of the wave mechanics. What are going to be the various features of a wave? How are these features changing with respect to time? And then you have particles, things that things that have very different properties from waves, classically speaking. They don't have frequencies, they don't have amplitudes, they don't have any of these kind of almost properties, you could say, but I'm getting a little bit ahead of myself. You just have what are effectively discrete points that are changing their positions with respect to time. And that's sort of all there is to it. So we have these two very different things, but of course, with the advent of quantum theory, the line between these two gets very blurred when you get to subatomic levels. And there are certain mathematical tricks you can use to get from one to the other, but what should we call it? Yeah, I go over some of the history of these developments in my Quantum Theory Made Easy series. You can check them on my channel if anybody's interested. But there is a way of interpreting quantum waves that tends to be more popular. That tends to be sort of the canonical way of interpreting quantum waves. Because when you have things that are supposedly particles, but that are behaving like waves, nobody knows what the hell this is. Nobody knows what the hell is going on. What does it mean for an electron to have a wavelength? What does it mean for a photon, which we used to think is just a wave? What does it mean for that to behave like a particle and scatter off of things? You know, what does this all mean? How do you have things that simultaneously have wave properties and particle properties? This doesn't make any sense. So there was a development in the late 1920s by, I believe it was Max Born. He was the one who first interpreted the wave function as a probability distribution, or something that'll give you the probability distribution if you take the square of its modulus. But let me try to gather my bearings for a moment.
Yeah, let's just back up for one second, if we can. I'm gonna try to parse out what he said to everybody else. And the way I understand it classically, if you know the position and momentum of every particle in a system, you have a complete knowledge of that system. You can say, okay, I want to describe this system completely. All I have to do is know every position and every momentum exactly of a particle, which obviously you can't do in the real world. Quantum does not allow that because of Heisenberg's uncertainty principle. But the theory there is that to describe the state of the system, you would have to know the momentum and momentum and position of every given particle. And so
yes, but
the wave function.
There's a more fundamental issue at play here, and that's a kind of incommensurability between waves and particles. You know, even with classical systems, you can describe the position of a wavefront, but the wave itself does not have a well-defined position mathematically. If you're drawing, you know, a sinusoidal wave,
The
you
leading
know,
edge
how
you
can you
describe.
say
The leading edge you can describe. The front leading edge of the wave.
the front you can describe, but the wave itself, you know, where is the wave located? Is it there? Is it there? Is it there? You don't really have that information. It's the momentum that you chiefly describe the wave by.
And that is tied up in the wave function itself. The psi function gives you the information of that wave, and then the squaring of that will give you the probabilistic density as a whole across the system. And also gives you the when you take the square root of that, it takes you back to give you the real component of where position will be across the system, which in a normalized system, the probability has to be between 0 and 1. There has to be
yes, but think of a classical system as well. And even in a classical system, when you're trying to describe waves versus particles, you are describing mathematically two very different things. And whatchamacallit, If you have a system that takes on the properties of both simultaneously, as you do in quantum mechanics, then the features that are particular to one, say the momentum that is particular to the wave description, is not necessarily particular to the particle description, where position is the dominant feature. So if you want to have a complete description of a quantum system, you can't have it because in order to have this complete description, you have to be able to know everything about the position, which is not possible because of its wave properties, and everything about the momentum, which is not possible because it has particle properties. So it's chiefly because of this incommensurability between waves and particles that you have this inability to completely describe the system.
Okay. All right. So let's go ahead and move on from there then. Because again, I'm only understanding it from the classical point of view. Basic particle physics. It does when I was learning about particle physics, and average Joe in here, by the way, is a nuclear physicist, and he had the same coursework that I had in nuke school. He was actually a nuke like myself, same training. The only difference was that he actually got into engineering laboratory technician work, which does a lot more of the water chemistry than I did. But we don't learn things from a quantum level in nuke school. We strictly are classically trained. Would you agree with that, average? Oh, you just probably get a mic check, Joe. By the way, hi, Joe.
Hey, Joe.
Oh, is he working? No, we can't hear you, Joe.
How's that? Is that better?
Yes, sir.
All right.
Welcome.
Good. Thanks very much for having me on. Just a point of information. I'm not a nuclear physicist. I do have a BS in nuclear engineering, but that does not make me a physicist.
All right. Pedantically, he's a nuclear engineer, but not a physicist. Okay, he's a smart dude, though. Either way. So, anyways, but would you agree that the nuke school, that training that we had, was classically oriented? Never got any quantum.
Well, I mean, we stuck our toe in the water of quantum mechanics, but we never went into actual solving of equations of electron position or anything like that. So
right, yeah.
So no, it was all basically, yeah, it was all basically Hayward mechanic on a thing that is radioactive and makes power, and we kind of understood. And we went into it, but we didn't do the 3D neutron transport equations and all the stuff that I learned in college later.
Yeah, no, we stuck strictly with the six factor formula, startup rate equations, xenon level equations, and what was the man, I can't remember some of them.
What you needed to know to
beta bar. Do you remember beta bar? I know we're going on a tangent like we used to do. Beta bar. Do you remember beta bar for?
Yeah. What they taught us was the applications of quantum mechanics as they resulted from the bomb projects. And that's really what we had to learn enough to understand reactor dynamics and stuff like that. But we never really touched on quantum mechanics or the different interpretations of it, or why they chose Copenhagen interpretation, or the real nitty gritty of the physics. We were in the engineering aspects, which is, run the reactor, make power, understand the plethora of different dynamics that goes on, so you can understand what's going on to a reactor, but not really the why.
It boiled down to how to learn how to go fast and go faster.
Yeah.
So no, that's a brilliant segue, by the way. I do want to get into the different types of interpretations. Copenhagen interpretation, right? The multi-world hypothesis, or the pilot wave theory actually is a different thing altogether. Matter of fact, pilot wave actually competes with Copenhagen interpretation. So that's a good question, though. Why did the Copenhagen interpretation, which the way I understand it is the interpretation that a wave function doesn't collapse until it's observed, and then only one of the possible outcomes manifest, the other outcome just terminates. No other outcome comes of it other than like the multi-world theory, or the hypothesis is that any possible quantum state that can occur will occur, and then it branches off. So, excuse me, what was the reasoning for the Copenhagen that you think was the reason that kind of was the prevailing thought that took over, Casey?
It was the first one to develop historically, as suggested by its name, and the people who were working on it and where they were. And when you get into actual pedagogy, when you get into actually teaching students about quantum physics, you don't really spend much or any time at all talking about the various interpretations of quantum physics. There are separate classes in the philosophy departments that discuss this. But inside of the physics classroom, you just learn how to do the physics. And historically, since this was the first one to be developed, this is the one that gets taught, and it has the least amount of philosophical baggage as well. People sort of just gloss over the fact that, well, all of the weird shit, they kind of just gloss it over. They say, here are the equations, here are what they predict, here are the experiments that show that this is the case. We know that this contradicts what you learned in your classical classes. We know quantum mechanics is weird. You can look into that on your own time, but in this class, we're going to try to learn how to use this thing. It's geared toward a very utilitarian mode of thinking.
Do you think that a lot of the differences are philosophical in nature? Because I mean, if you look at the Copenhagen interpretation as opposed to the pilot wave, which I'm going to try to get into a little bit, as long as they work, as long as they describe exactly what we're seeing as an observation, that's the big thing. I mean, does it actually indicate or give us a explanation of what's going on? There's a huge philosophical differences between the Copenhagen and the this deals with the heart of realism and locality. And those, to me, especially realism, is a philosophical thing. Are there properties that exist independent of our our observations that exist in reality in the system, a local hidden variable? That is philosophy more than physics to me.
Yes, you're correct. And I should point out, it doesn't really matter which interpretation you're using, at least at the level at which quantum mechanics is taught. In principle, you can interpret the results of your calculations in terms of many worlds, Copenhagen, Bohm, pilot wave, whatever. What should we call it? You can interpret it any of these ways, but the problem, and this lies at the heart of the why we have quantum philosophy in the first place, is because all of these interpretations utilize the same maths. The same calculations are used in every single case. And because of this, the various theories, this one versus that one, Bohm versus pilot wave, they're what's called underdetermined. There's no evidence that particularly favors one over the other. It's ultimately what quantum mechanics means is going to be a matter of personal taste. Since Copenhagen carries the least amount of baggage in that regard, that's the one that we sort of go with. It's the shut up and calculate interpretation.
And Copenhagen tends not to like realism at all, and pilot wave doesn't like locality. And
Copenhagen, from the way I see it, Copenhagen doesn't explicitly say one thing or the other about realism.
It can go either way on realism.
Yeah, it tends to be more agnostic on this issue. Basically what Copenhagen comes down to is if you do this experiment, you're going to end up with this probability distribution. And what that means, people can tease that out on their own. Bohr, I think, did embrace non-realism, and Copenhagen is most closely associated with him. But Heisenberg, I believe, was a realist. I may be incorrect on this, but I think Heisenberg was a realist, and he was also closely associated with Copenhagen. So I don't know if it's correct to say Copenhagen is explicitly realist or anti-realist.
No, I don't think it's explicit. I just generally I've seen more people express the Copenhagen as not having realism. But let's talk about those mean real quick. Again, from my understanding, the realism approach is that there actually are properties that exist independent of our observations, mind independent, that exist in the universe. We'll call them position, momentum, charge, any parameter that you want is something that actually is a real thing. The locality aspect is that information is traveling such that it's within a sphere of influence that it has to be less than c. So if you have two particles that are far, far away from each other, If there's a theory out there that says, okay, one communicates with the other and is actually a messenger that goes from one to the other, then it violates locality because it's not within the sphere of influence, which you would have just within the limit of the speed of light. Is that a decent enough way to explain it?
Yeah, that's correct.
Okay, so that gets into what we would probably get into at some point here, entanglement, because entanglement just is one of those strangest things in the world, how that works. But let's kind of bring this back to the Bell inequality here, because this is the crux of it. Because somebody had asked me before, what is the Bell inequality and why is it so important? And the Bell inequality just kind of states, in a nutshell, that if you have a hidden variable model, thing is a hidden variable model that exists that can tell you all possible states in a quantum mechanical system, unless you have what's called the pilot wave theory. That's the one theory that does allow for hidden variables, but they're called global hidden variables. They're hidden variables that are in the equation itself, that across the entire system, but not localized. So the global hidden variable is not the same as a local hidden variable. But the whole thing with the Bell inequality is basically, if there's a really good video on this that I think it was Holy Kool-Aid had shown on his Facebook channel the other day, or Facebook page. It was great. It was by 3 Brown. Have you ever watched that channel? Anybody? It's great.
Yes.
Brilliant channel. Is it good? Is it good? Yeah, I love their channel. And they had a really good that and Minute Physics. Brilliant. But they're explaining these things, and basically, if you start off where you have polarization of light, you have light that is traveling in a certain polarization with respect to your axis. Okay. If you have a 90-degree polarization, then a filter, then that's going to block out anything that's polarized with a 0. So let's say you have 0 polarization, you have a 90-degree filter, it's going to not allow that light to pass through. It's going to actually absorb it. So you would think that if you have a light passing through that, you put a filter on it, it should drop it down by a certain amount, which I think is half, correct?
Yes, think about it this way. This is for the audience in case they're not really sure what is meant by polarization. Imagine you have a tube and water is flowing through this tube. But at the end of the tube, you have a bunch of vertical lines, a bunch of vertical grading. And for whatever reason, whatever water hits this grading, it doesn't go through the tube. So all of the water that doesn't go through it stays there. But you have these sort of like lines, these vertical lines that are passing through.
Yeah, that's a great way of explaining it.
Yeah. And then you, at the end of this, then as you keep on going, you have a bunch of lines that are 90 degrees to that in the tube. So you have this grading that's cutting even more of the water that's passing through out. So what you end up are, in this kind of cartoonish picture, these kind of square droplets of light that have not been touched by either of these gratings. So it's effectively a kind of filter. It filters out everything that doesn't have a particular orientation. When you're thinking about it in terms of light, the light has a specific property. Whatever it is you're filtering out, whatever remains, that's what ends up being polarized.
So basically, if you think of these things like vertical slits, guys, some of the waves that are going to be polarized vertically will be able to pass through it because they're oscillating in that direction, so they can pass right through it. But if they're going in the horizontal direction, they can't pass through it. Way to explain it, because you have two components to any kind of wave. You have electric field and you have magnetic field, and they're always going to be what's called orthogonal to each other, which is a fancy word for 90 degrees difference. So you have these two types of fields, and when we were like in nuke school, one of the things we had to learn was vector physics, like vector analysis, and how things go through a field. In a system, you have a force pushing on a particle, and that vector that is pushing on is determined upon a lot of factors: the strength of the field, the orientation of the field, the magnitude of it, rather than just if you just have a scalar thing. So when we're talking about polarization, we're just saying, okay, what is the orientation of the oscillations of the fields as opposed to the filter? Okay, I guess that's an easiest way to explain it. So with the by adding a middle filter, you actually can increase the amount of photons being produced at the end. Filters where you have a certain amount of photons going through. Okay, so if I put a filter, I put another filter in there, I'll have a certain amount of photons going through. Now, you think you put any more filters in there, common sense wise thinks that it should reduce the amount of photons you have at the end. The more filters, the more photons that you should be blocking, correct? That's the classical way of looking at it. That way. Filter in, it actually allows more photons to be going out at the end. And that's the Bell inequality in a nutshell. If you add up all the of where of how many photons you should be having at each stage of the filter, you're always going to be greater than or equal to, again, doesn't make much sense classically, right? Because classic, you think you add more filters, you have a diminishing result. Explain it from layperson. So Casey, if you please take that and run with it and kind of explain that in a way, because it's not intuitive by any stretch of imagination.
Well, maybe people can understand it better in terms of set theory. Typically, we think if A is a subset of B and B is a subset of C, then A is a subset of C. But what Bell's inequality seems to suggest is that there's some cases where A is not going to be a subset of C. So, maybe think of black and white balls passing through a tube, and there's a filter in the tube. And the first filter only allows white balls through. So the white balls go through, and the black balls get left behind. And then there's a second filter. So let's say you start out with 100 balls, 50 are white, 50 are black. After the first filter, only 50 balls remain. And they're still passing through this tube. And then let's say, let's say some of these balls have smiley faces drawn on them and some of them are plain. You have a second filter, and this one filters out all of the plain ones, so all you have left are the smiley faces one. It can be the case that after the second filter, let's say you start out with 100, 50 of them are white, 50 of them are black, and of the white ones, 25 are smiley faces and 25 are plain. The balls go through. Now only the white ones remain. Then they go through the second filter, and now intuitively, you would expect that only that a smaller amount would remain because it's filtering out everything that doesn't have the ball with the smiley face. But that's not always the case. Sometimes you end up with more white balls that have smiley faces than there were white balls to begin with.
Which is impossible classically speaking, though.
Yeah. This analogy is a little simplistic, but it basically gets to the core of what the problem is.
Yeah, I've seen Bell inequality actually expressed in terms of set theory, and it does make sense that way. I mean, if you're looking at it as subsets, it makes sense, but at the same time, it's still that whole counterintuitive thing because if I have two filters and I'm blocking half of my light, because again, let's assume a random thing, so you have some photons that are horizontally polarized, some that are vertically polarized. Filter, you have a certain amount that are blocked, then after the second filter, you have a certain amount are blocked. And by sticking in that third filter, you now take that first filter, and and it actually mathematically comes out to 15%. And then you take the amount of photons that are blocked by the second one is only 15%. So it only comes out to out of the 50% that we would expect. That's the inequality. So that's what's saying that it's always going to be less than that. So it's not really a subset of a subset equality there. You would think that anything that in one set of a main set, but just kind of craps all over that, it seems.
Yeah, and what Bell's theorem basically says is that whenever you have a theory like quantum mechanics, a theory that has the properties of the mathematical properties of quantum mechanics, that you're going to end up with results that make it impossible for both realism and locality to coexist.
And that's what Einstein's local realism was. We have both of them coexisting. both of them being true. By the way, let me welcome Mel in here real quick before I get a chance to go on here. Mel.
Hello. Sorry,
Welcome.
I'm fashionably
Welcome,
late.
Super Scientist Mel. She's such a scientist. It's in her name, so she must be a scientist.
I have been that, yes.
Yes. Mel, have you met Casey before? I don't remember.
I might have. I've been all over the place the past few months.
Wow, he's not that memorable, guys. See this?
No, he probably is memorable. I'm just terrible with names and faces. I have to say a name. If I say a name 3 times wrong, it's stuck in my head wrong forever. That's just how I am. So it's the same way with remembering
you have to go to his
people.
channel.
Okay.
Go to Casey's channel. I didn't put many links in it because I kind of been stripping my videos down because I've been demonetized like hugely. In fact, even yesterday's video was fine. All of a sudden it got demonetized. Whatever. But I'm trying to figure out what the hell keeps demonetizing my videos. So I've just stripped away everything. So I'll put the links in afterwards to like Casey's channel and all that kind of stuff.
Okay, cool.
That's a brilliant series on quantum mechanics as well as his takedown of Ken Hovind, if you remember that back in the day.
Okay, cool. Cool beans. I will check out his channel.
Mel's new, Casey. Forgive her. You know not what to say.
I am new to the great debate community. I have my own thing I do usually, but Steve is like, hey, come talk with us. And I'm like, okay, you keep inviting me back for some reason. I think you're on drugs or something. So,
we haven't figured out why we invite back half the people we invite. I don't know. No, I love your channel. It's a great channel. If anybody has not subscribed to Scientist Mel, go check out her channel too. I'll put her link obviously in the video description.
Somebody from the great debate community showed me about a service where I can stream to Periscope and YouTube at the same time, and that was like Christmas for me. So.
Yeah, you can do that. Yeah, there's a couple different ways you can do certain things, but most of them are all paid services that I don't want to invest in. So
that's okay.
Yeah. So what do you want to add real quick? I mean, what is your knowledge on this particular topic? If you have any you want to
on Bell's theorem,
throw down. Yeah, or quantum in general.
Quantum in general. If you think you understand quantum, then you don't understand quantum. That's usually
it's a nightmare. I mean, just Broad-Ket notation alone confuses me. I'm not going to lie. I don't understand quantum worth a damn. It's one of those things where I get the concepts. Like Bell Inequality, the concept makes sense to me.
Mm-hmm.
Right? But when you look at the math, oh yeah, no, it doesn't. But it's just one of those. And we had some pretty advanced math in nuke school. I mean, we weren't joking around when we were doing reactor kinematics and neutron flux densities and all this stuff. It required a little bit of in-depth knowledge of mathematics. So
yeah, my knowledge
and expect you to know it too. They didn't teach you the math as well as they think they should have. What's that?
Yeah, my knowledge of quantum tends to just graze a bit on physical chemistry in regards to that. So if we're talking about instrumentation as far as detection and things like that, that's where I have to that's where my limitations of quantum kind of lies in regards to, I noticed you were talking about photons earlier and things like that. So let me see an example, how a particular spec would run, spectrophotometer, that sort of thing. What kind of spec are we talking about? What is that? One of the diodes in a photomultiplier tube, things like that. So it is in regards to quantum, that's kind of where the limit of my knowledge is. And if we get into theoretical stuff, I can understand some of the math, but if you want me to work out the math, I might have to swear a lot. So, because I don't like doing a lot of the calculus 3 that's required for some of the quantum.
But you just admitted though, even in these types of experiments that you utilize, even when you use things like spectrometry and things of that nature, you have to take into account quantum mechanical part of the real world. You have to factor them in, no matter how much you hate them. They come into place.
Even in computational chemistry, I was working with software called MO software. It's a molecular orbital type of simulation where you could put in the crystal structure of a protein receptor. And then the project that I was working on, we had known antagonists for a particular receptor, and it's highly expressed in cancer. And so the hope would be to find a relatively strong antagonist to make chemotherapy more effective, because this particular receptor is associated with cellular rescue. So cancer cells tend to just save themselves over and over and over again instead of undergoing cellular death. Well, anyway, so the way that computational chemistry with this particular program is based, it bases it works a bit with kinetics, and a little bit of quantum is involved with that, to where it tries to calculate the lowest energy form possible, and also the shape of the ligand in the lowest energy form possible. It may not always be that way, but that it tries to use those particular calculations. So quantum is everywhere. It's just
so the ligand's what's actually sticking out of something. It's some kind of a functional thing where
well, the ligand is a compound that fits into the receptor that either initiates or stops a particular series of biochemical processes within a cell. In this case,
is that
huh?
Go ahead.
Okay. In this case, this particular receptor is called the LPA2 receptor, and when it fires off, the cell undergoes cellular rescue, so it saves itself. Cancer cells are, well, cells that no longer function properly that can turn into cancer undergo what's called apoptosis, cellular death. So this particular receptor, if it's turned on constantly all the time, or if it's highly expressed in a cell, the cell is constantly saving itself from that programmed cellular death. So theoretically, if you shut those receptors off with a ligand that fits in that receptor and doesn't fire it off, then the cell can't constantly rescue itself. So the ligand is a compound that fits within that receptor and either turns it on or shuts it off.
Okay, so I know this is kind of going away from topic. So if I'm mentally picturing this, you have some kind of receptor, protein receptor, I assume, that the ligand will bind to, and then that stops it from not undergoing. It stops it from it not being able to go through apoptosis.
Right. It stops it from saving itself, so it undergoes apoptosis.
Yeah, right. It stops it from not going, because normally a cancer cell would not have apoptosis and it would continue to divide uncontrollably, right? Yeah. So well, I have to wrap my head around this stuff. So
yes, it's hard sometimes. But the computational chemistry aspect of that has to take into consideration quantum mechanics, and also in regards to kinetics. And so in order to determine the lowest conformation state for energy, it has to take into consideration how electrons and on these particular compounds would be in their lowest energy state.
And that's directly related back to the conformational states. The form of it are directly related to the type of orientation of the electrons, right? If you have certain kinds of bonds, like sigma bonds and pi bonds, these things directly go into the shape of the molecule because of the different probabilities of where the electron is going to be forming in the cloud.
It takes into consideration the probability of where those electrons would be and what the lowest energy state would be. That would be the most likely case, but it doesn't always happen that way.
See, all this stuff binds together. That's what I love about science. It's like, look at, you learn a little bit about pi bonds, and you understand a little bit about orbital mechanics, and you understand the shells, right? Well, that translates to all kinds of different things. In your case, it's translated literally to the lowest conformational state of, like, what you said, a ligand, which I think is amazing, because it's just everything bonds together. It's beautiful. It's a beautiful thing.
It's like a symphony. Each one's a different instrument that contributes in its own way to the entire piece.
And do you think, though, this is kind of the reason when people go into STEM fields, they have to at least have an understanding of the basics, because the basics will translate into more specialized things. And this is one of the things when I see when we talk about the what we call the clown car posse, they don't want to learn the basics. They don't know the basics. They've never had any of the basics. And so they're jumping into these fields without even understanding what an orbit is. They have no idea. I mean, in fact, I know this for a fact because Jada asked them, what's an orbital? No clue.
It is a foolish man.
What's that, King?
It is a foolish man. It is a foolish man who builds his house on sand.
It gets washed away pretty quickly. And that's what they do, though. And it's notable. That's why we kind of go, we want to have things like this. We want to have talks like this. And you know how many of them are going to be listening to this? Zero.
Zero?
Not a one. Not a one.
Well, I mean, they probably are, but they're probably not going to understand anything of it.
Well, that's a difference, though. I mean, this is not stuff that's easy. This is not stuff that the average person is going to go, oh, I understand this now. But at least they have the ability to ask questions and learn something that maybe they weren't familiar with before. Maybe if they just learned one thing. Oh, what's locality? Oh, I remember what Stephen or King said or whatever said about locality. This is what they're talking about now. If they have any kind of takeaway like that, I'm happy.
These people probably suffer a degree of some form of personality disorder, whether it's narcissism or something a little more on the antisocial or obtuse side of the scale. But those aren't deficits that you would expect them to be overcome. You know, even with the maximum amount of therapy, maximum amount of medication, those kind of conditions they don't resolve themselves, unfortunately.
Well,
I mean,
what about? Oh, sorry. Go ahead.
No, I'll just say real quick. Do you think it's worthwhile for someone to seek out maybe some kind of psychological thing? Because I do think there's an underlying pathology there. I honestly do. I'm not qualified to say that. I'm not saying that I am in any way qualified to say that. I'm not. This is pure my opinion. I just think they're mentally messed up. No, but
I think it's almost to the point where it's obvious. But the problem is, people with those kind of conditions have very poor insight that they have a condition. It's almost like a form of being in denial. They don't realize that there's a problem, that they don't interact appropriately with others. They don't see that. They can't empathize and see things through other people's perspective to kind of self-critique. And they don't realize that there's a problem. So they're less likely to seek therapy. Basically. Yeah. That's a nice way of putting it. Mm-hmm.
Yeah, the social skills are not there. Look, we're having a great hangout. We have great, intelligent, brilliant people in here, even myself excluded.
Except
clearly.
Tonight, of course.
I know what you know. You got it going on. Don't underestimate yourself. I've seen what you write. You do have a very good understanding of a lot of these things.
Okay,
but
thank you.
I was going to say something about cognitive biases, because there's a whole lot of those. And
sure, go ahead.
I think oftentimes there may not necessarily be a pathology associated with it, but overconfidence is one form of cognitive bias, where you think you know more about something than you actually do. Another thing
Isn't that the Dunning-Kruger effect?
Yes. Yes. So there's overconfidence involved. There's being blind to your own biases. That's a bias in itself. You have individuals who try desperately to find patterns in a particular thing, like a roulette wheel. That's a type of bias, when it's really, there's not a pattern there, but our minds try to find patterns in things. That's why we see faces in doors, like wooden doors, like, oh, look, or we look at an old mirror and we're like, I think I see a ghost in there. That's, our brains trying to find patterns in things that are entirely random. That's a type of bias. So,
pareidolia and apophenia.
You have, everybody has bias. It's just some are so blind to their own biases that they can't even acknowledge the fact that they have bias. I have bias, and I try really hard to keep it in check, because you cannot be objective with data knowing that you have bias. That's why we have instrumentation. That's why we have peer review. That's why we have other people look at our stuff. That's why we use multiple types of detection for a particular thing, to make certain what we're seeing is actually accurate and we're not piecing it together, because we really want this to be correct. So, but I think a lot of it is cognitive biases, because people just can't get past, and it's painful, especially if they look at evidence that contradicts something that they've always believed, and
too.
Do what?
It's also you said cognitive biases. It's also cognitive dissonance, and also our minds strive for internal consistency, which not necessarily means the truth.
Mm-hmm. And also we have confirmation bias, so
absolutely.
We look for evidence that reinforces our perspective, so.
But here's what confuses me, Mel. We're talking right now about quantum mechanics. We have Casey in here who's actually gone through a lot of schooling to learn about some of these things. We have Joe in here who's, obviously took a lot of courses in nuclear engineering. These are not something that are just, my faith and my beliefs in a deity changed how the science works, right? This is something that should be ubiquitously even across the board, no matter what your ideological belief is. It's not now. If somebody wants to come in, if any one of them want to come in and say, "Look, you know what? I'm a big fan of the multi-world nation. Let me explain to you why that's better than the Copenhagen." That's something that's worthy of discussion, right? We would love something like that. Right, because those things are up in the air, right? As I think Casey brilliantly said, these types of models are how which works for you. And I think the Copenhagen is probably one of the easiest, but it describes the system, and so does the other ones. Now, if they want to argue that one is better than the other, those are debatable things. I think that's great. It's a discussions, right? They're just saying outright, "Hey, you know what? Your science altogether is wrong," but they don't give us anything.
Well, they benefit because they benefit from the hard work science has done over the years. I mean, that always gets me.
I will say I do find, in regards to cognitive biases, you can encounter scientists who have overconfidence in Dunning-Kruger. They think they know more about a particular thing because it's their field. But even then, if they think they know, everything about a particular field. Well, I've been in this field for 30 years. Well, science changes so often. I mean, when I was in cancer research, we didn't read papers that were more than 5 years old because they were already outdated because of how fast the research was going.
Yeah.
So, it's just the Dunning-Kruger overconfidence can be seen amongst experts too. So it's there.
When it comes to experts, my suspicion is that it may have perhaps less to do with Dunning-Kruger and more to do with a kind of defiant professionalism. Here they were working their ass off in this field for 30 years, pursuing this tiny little corner of scientific knowledge. So presumably, they really don't want it to be that all of their hard work was in vain, or maybe that's the perception.
That also applies to like other things too. Like if people invest their time and money into things, they want to make sure that it's well spent.
Yeah. So what I'm saying here what I'm saying here is maybe in the case of the experts who get a little bit arrogant, that may be that may be I don't want to say sunk cost fallacy because that gives the wrong connotation, but the same kind of psychology is going on there than perhaps Dunning-Kruger.
Yeah, no,
sorry, I just wanted to ask KC what the other thing is. Like, I can't even I don't remember what he said. I can't even pronounce it now. Like it was Dunning-Kruger, and then he mentioned something else.
Sunk cost fallacy.
Yes. Can you explain that?
So imagine you're going to a movie theater and you're seeing a terrible. Let's say you're watching God's Not Dead, and
oh God, you're trying to kill me. That was a joke. Go ahead.
Well, you go in expecting that you're going to watch this amazing movie that's gonna get you connected with your Lord and Savior Jesus Christ. It's gonna be so inspirational. You're gonna stick it to those evil atheist professors. But then you see this piece of shit movie with Kevin Sorbo acting really bad, like it's just the stupidest shit. And as you watch this movie, you think to yourself, "Man, you know what? I spent $13 on this piece of shit. I may as well write it out." But that's a fallacy, because the time that you're spending watching this piece of shit and not enjoying yourself is time you could otherwise be spending on something that'll give you greater returns on your happiness or even money-wise.
That's why when somebody says somebody says that to me, I'm like, you know what I mean? I just don't.
Basically, in a nutshell, the sunk cost fallacy is pretty more simplistic than that. It's basically, I've invested so much time in this, and instead of going in a different direction, I might as well invest more wasted time on it. And
yeah, no, I get that. I get that.
Basically. But I think
so. In the case of our arrogant 30-year researcher, it may not necessarily be that he genuinely believes that he knows. Well, what I'm getting at is it's maybe a little bit of a different phenomenon from Dunning-Kruger. There, I'll leave it there.
Yeah, well, people don't want to have to admit that a lot of their life's work was for naught. And you had pointed out that with Humphreys, right? Humphreys has agreed many times to discuss off air and in writing some of the things that I have brought to his attention, like, okay, have you solved the heat problem? How did you arrive at this? What is your evidence for accelerated decay? And I don't know if you know this, but we have coming up here in a couple weeks, Casey, we have Dr. Henke and Dr. Lachey. One's a PhD in geology, one's a PhD in physics. They both wrote for the helium diffusion rates against Humphreys. They're doing 40-minute PowerPoint presentations each, 30 to 40 minutes, and they're going to be talking about this very subject and explaining not only why Humphreys was wrong, but I think they're going to kind of go in and say directly that Humphreys deliberately was wrong. And I didn't want to make it into a mudslinging thing, but if they can actually make that case, I'm fine with that. I think they do actually think that Humphreys was deliberately deceptive in some of his works with this. And I think that it may be a saving face thing. It might be a protective mechanism he has, because he's kind of dropped off the face of the planet a little bit, and he won't talk about this stuff in real time. And it could be maybe that he just doesn't want to recognize that his life work is basically crap. I mean, is that possible?
Yeah, probably. I mean, having worked with scientists who, and I have worked with scientists who I would sit there and I would question their methods. They would get personally offended. Like, no, you have to run it this way. And I would run it that way, exactly as they would say, even though I had questioned them. How dare I question their methods, first of all? And secondly, they would get mad at me for following what they said instead of doing what I wanted to do initially, which was the correct thing. So there's a lot of sometimes butthurtness in academia, especially if somebody who has all of this pressure to get money to the university in the form of grants, and they're pushing their graduate students saying, publish, 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 we got to do all of this.
For the term ego, not
there's an ego thing there. We're like, well, I am so and so, and I postdoced at Johns Hopkins, and I did this, and I'm sitting there going, yeah, but you wrote nanometers, and you meant, micrometers, and so that's a big difference when you're talking about
mistakes. Mistakes do happen no matter what title you have. Sure.
And then I would say, this particular way that we're doing this, we could do it this way, it would be more efficient, and let me show you a way. No, we're going to do it my way. I'm the one who did this, and I'm the one. And they would just start rolling out their credentials, and then I would bring it up later. Well, I think since that didn't work, let's try this. Why didn't you bring that up before?
I think that's one of the reasons why people have a I don't want to say hatred of professionals, but a dislike.
I think a distrust.
Yeah.
Distrust. That's better.
That's a lot of the same kind of thing in the IT and computer, maybe not so much computer security world, but programming world. People will trot out their credentials and insist that this is the best way to do stuff, even if someone newer might have a better idea.
See, that's the thing that makes me nuts. It just makes me nuts because we need diversity in the sciences. People are not meant to be wired a specific way. Well, if you think this way, then you should be in the sciences. We need people that across the board that think differently, because that's how you get problems solved. I mean,
now that I think about it, I think our educational system tries to do something similar. Because everybody learns differently, but they expect you to learn, to learn one way. I could be.
Yeah. Well, having been a teacher, let me tell you, I used to teach in the state of Tennessee. I taught in the state of Tennessee, and they expect every single child in high school to take courses to push them towards going to college. And so they convince all of these kids that they all need to go to college, and you have to take all these classes. But the thing is,
crippling student debts.
Yeah, and crippling student debt. But the thing is there's a lot of students who will not, sure, chemistry is important, biology is important, but there needs to be separate classes for students who actually intend on going to college. Not every child is meant to go to college. To be quite frank, a lot of them don't want to. They want, and where I live, it's heavy farm stuff. And so they want to go into agriculture. There's ag science, stuff like that.
I
They're not
totally
ever
agree
going to
with-
go to college. They need to be able to leave high school with enough of an education to either go to college or start a vocational job. They don't need to necessarily go to a separate school. They should be getting that where they leave high school ready to work, because a lot of these kids in Tennessee want to do that. Now, the ones that want to go to college, I was one of them. I grew up in Tennessee, and I'm like, I want to go to college. I took all the things that I needed to take in order to go to college, and that's what I did. But not every kid is meant to do that, and there's nothing wrong with that. I'm so sick of people thinking that every kid needs to go to college or there's something wrong with them. No, every kid doesn't. I need a plumber. I need an electrician. I need somebody to fix my car. Don't ask me to put plumbing in my house. I will cry. So.
There needs to be a standard. I think there needs to be a general standard. However, there needs to be some tailored toward the students' end goals. And if the student decides to change that afterwards, fine. You could take remedial courses in college. You can take things to get you up to speed. It's going to take longer that way, but that's the decision that somebody has to make in high school, whether they're going to go to college or not, or even before then. I would say start in junior high. But that's fine. I think that students should have those options. Like my daughter knows she has to go to college. She has college fund. There's this, if she wants that money, she has to go to college. That's the stipulation, right? Not all kids do.
To be quite honest, I've known people that made more money than me, and I had 3 degrees at the time. So,
the money.
Hang on a second. The money my daughter has is on the stipulation that it's for college. Period. She can't use it for anything else.
In the Soviet Union, the way that they ran their education system was the students who did better than the others, they were the ones who went on to university, whereas the students who didn't do so well, they would be sent to trade school.
Which I don't know if that really works, because that's kind of implying that if you can't really hack it, you're going to end up in some kind of trade. And I don't believe that. I think some very exceptionally brilliant people go into trades. You have to. I mean, there's certain trades that I just could not do. I'm not smart enough to. So I don't think there's any correspondence between not doing well academically and having to resort to going to a trade school only versus a college.
At the nuclear power plant that I work at, as an engineer, I am often the lowest paid person supervising a job.
The janitor gets paid more than you.
Yeah, honestly, some of the nuclear welders, they're getting 90 an hour, 100 an hour. Welding is and plus they get overtime. They get, if they're working off shift, that's an extra 4 hours. There's so much pay out there, and here I am on straight time.
Why didn't you take the nuclear welding? You took metallurgy like I did. You've had to do some welding in the past. Matter of fact, most of the machinery we had to do our own fabrication.
No, we never did any of that on the Virginia class submarine. So
you're on a sub. Okay,
yeah,
that's the difference.
We didn't
on a surface. We had that ability to fabricate our own stuff, and we did spot welding.
No, we had a lathe, and we never used it once.
Really? Oh
yes.
My God! So you don't know the joy of getting cut with those shards that come off?
No.
That's a joy.
Oh my God! You've never experienced pain. It could be a microscopic cut. But let me tell you, when you're working with a lathe or tooling and you've got that stainless steel coil coming off, and if you're not wearing these special steel gloves or something, and you try to even move that thing, it's gonna slice you. It's painful.
We played Danger Nut a lot, but
so really you didn't have to do any kind of welding? I'm surprised. We had to do a lot of tack welding.
No, we so we have the nuclear emergency welders. And they're rated to weld on stainless steel, and they only do test welds. They're not allowed to weld anything else. We did weld. I think we welded the seat back on our stationary bicycle, and that was.
So who does the welding for the primary plant then?
So when we go to the shipyard, they do that all.
So you just have to be a civilian government contractor welder.
Yeah, so all our welders are emergency welders, and the idea was primary to atmosphere leak. We could shut down short term, send somebody in, patch the leak, and then get back to base or continue with mission. But it was always going to be a temporary one because we want any sort of real welds to be, X-rayed, go through radiography. It's got to be inspected, that kind of thing.
Oh yeah, I mean, I never did any of the X-ray radiological. Actually, have to like check for defects. That's a special thing altogether. But usually a person comes in, they'll do the weld, and then somebody else comes in and they actually
they
test
bring in
to
the
see if the
source,
weld
and
is
then it becomes a high rad area for a little while, and they take a bunch of shots and stuff like
Right.
that. It's the same.
But that
with
should be more your area then. You've taken radiological controls. You had to do radiological supervisory things, just like I have. Control point access. Remember that?
Yeah, I remember
Fun stuff.
control point.
I just want to
Are you
say I
on the-
want my own emergency
Sorry.
welders.
We're reminiscing. Right. I don't
I
get a
just
chance.
want a team of emergency welders. They can dress like minions or not. That's entirely optional.
You just want somebody like Magic Mike to do your welding for you. That's all.
Oh no, that's not my jam. Mm-mm.
That would be very.
I'm more of the
interesting.
Kingsman, Colin Firth.
Oh,
Let's
okay.
talk about the Kingsman.
But I don't
Manners
get-
maketh the man.
I don't get a chance to talk to many nukes because that one guy, Sean, said he was a nuke, and I still think that he probably had some kind of nuke training.
I think he is. What I think he was trying to get around was saying was he was a nuke and he helped or like did some peer tutoring of other students in the nuke
Dude, he said he wrote peer
program.
review papers in nuke school.
Yeah, and that's a fucking lie.
Totally.
I shouldn't curse. I'm sorry.
Total. It's okay. I'm gonna get demonetized no matter what at this point. I think.
Awesome.
I think they just flagged my channel as a
Yeah,
whole,
so
the automatic-
there exists no peer review process in the Navy except if you go to the academy. There's stuff that or the War College.
And once again, who did the water chemistry control on the reactor, both the primary and the secondary?
That would be the engineering laboratory technicians, which are a division of mechanics.
Which would have been your rate.
So-
Okay, never mind.
Yes, my rate.
Yeah, not the
I sampled the primary every day for 18 months, oftentimes twice a day. I've drank primary coolant before. Yeah.
Really? You've
Nobody else
actually
did it.
drank? I mean, obviously, most of it. I mean, the chemicals. If I remember chemicals for the primary, oh my goodness. Okay, this is what chemicals we had to work with. We had to work with, and this was a secondary sodium
you guys-
hydroxide.
Okay.
Let's see, we had to work with what was it? The soap that we had to put in there, triphosphate.
Yep. TSP, DSP.
Phosphate and sodium triphosphate. Those were the two big ones that we had to use. And then
Yep.
we'd use silver nitrate for the turbidity test to test the salinity levels.
Yep.
See, you know what's funny is after 25 years, I actually still kind of remember something. I'm actually
Yeah,
kind of
so-
surprised.
So it's going to be a little different because you guys
Hang on one
did
second.
you guys
One
have
second. Yeah,
AVT?
One sec.
Yeah, I'm sorry.
King's got to take off. Hey, King. Sorry we didn't get more into detail on this. We have a tendency to go tangent. It's just the way it is, I guess. But next week, the Living Dinosaur wants to hook up, so maybe we can kind of go down and talk about something that he wants to talk about, which is more biochem stuff. Is that cool?
Sure, sounds good. Yeah. By the way, hi, Jackie Kite.
Hi. Happy holidays.
Likewise.
Yeah, happy
See
holidays,
y'all
man.
later.
Happy holidays.
Bye.
Let's try to catch up next week before the holidays. We'll figure out something. I know your time is limited, but I'm so glad.
Hit me up. We'll figure something out.
We will. You guarantee it, man.
Are you still doing the King Crocoduck Award or no?
But
The
He hasn't
golden
done it.
crocoduck, that's
Golden crocoduck?
that's
Yeah, that's been a
potholder, and
couple
that's been
years.
dead since
That's potholder.
2014.
My bad.
But I got the chance to talk to Potholder not too long ago, and that was amazing. That guy is just awesome. So, but anyways, you were asking, Joe.
I don't remember.
You were saying something about the types of tests that we had to do.
Oh, did you guys have all volatile treatment because you were on a cruiser?
What kind of treatment?
All volatile. So
All
carrier.
volatile.
So
doesn't
carriers
fit.
now use a different chemistry treatment for their steam generators. But you might have been on a destroyer-based submarine platform
I was on both. I had to qualify on S1C, which was a combustion engineering subplant, first generation, and then I actually had to qualify on the destroyer second class by General Electric.
Okay.
Which actually made a lot more sense to me. The first plant was basically, it had SSMGs, ship service motor generators, to convert the electricity into battery and then back and forth, right? Which I mean, that was a lot more the EM had to take care of that, right? The electricians made, but we had to learn the theory.
Good.
I was just going to say that one thing about people have to learn in the military, or about the military, is that you cross train like you wouldn't believe. It is like, if that person died, you have to be able to take over their station, kind of stuff. So you have to know almost as much as people's actual in-rate stuff a lot of times.
What the best thing I ever heard was so this is kind of weird moving to the civilian industry. A lot of people hoard knowledge because knowledge is power, and they understand that if they share their knowledge, they could be replaced. But in the military, we know that we are going to be replaced. Like, I could be killed at any moment, I could be wounded, but in a couple of years, I'm going to leave.
Yep.
So for us, knowledge empowers, and we share it with everyone we can. So all the time, I sat down with other mechanics, electricians, officers, to teach them about everything that I do, show them how I do it, because I could die in 5 minutes from now, right? Chinese could hit us with a torpedo, and now an officer has to run part of the engine room, and he's not supposed to, but he might have to. So
and how many people do you think you qualified? Obviously, you had your dolphins. I had my ESWAS, which is the equivalency. Once you get that, you can sign off anything on the boat. I mean, you're considered to be top dog as far as knowledge. You've earned the highest amount you can get is when you get your wings, your ESWAS, or your dolphins, depending on where you're at.
I would say the only thing higher than that would be the engineering watch supervisor or the engineer officer of the watch. At least
right. Okay, that's true. And the engineer officer of the watch has to be an officer, and the engine room watch supervisor has to be a chief or higher, which I wasn't. So
yeah. So to translate that to civilian world, an engineering officer of the watch would be a senior reactor operator at a nuclear power plant. That's a 150 to 230,000 a year position, which you don't need a college degree for. And you are the overall person in charge of an entire nuclear reactor that makes a ton of power in the United States. You have to get NRC certified. There's a license, all that stuff. And,
so where would you place me? I was an engine room supervisor, and I was ESWAS qualified. In the civilian sector, how would that translate?
So they have this thing called a field unit supervisor in the civilian nuclear power world. And that is, so you were engine room supervisor?
Yep.
Right? Okay. So they have this thing called a field unit supervisor, which he's not quite a SRO equivalent. But he's more of the, I don't want to say the engineering watch supervisor, but he's more of that role. But other than that, everyone else is just an auxiliary operator. And all of that is, right, it's kind of weird because they only take logs every 12 hours. So there's not an operator in the space of every single space in a civilian nuclear power plant.
It's still a supervisor position, though, right? In the
it would still be a supervisory position.
What would the pay equivalent be? Just curious.
The pay? You're probably looking at one with all the overtime and stuff like that. You're probably just under 170.
And I couldn't even get a job in the civilian sector for the last, back. I mean, when I moved, I was busting my ass trying to get a job around here. Couldn't find anything. Matter of fact, the one place. I even knew the person. They had known me, of me. I think they met me once, but they knew of me in a prior job because I've been in that company 6 years. And she was like, "What you're applying for is way below what you should have. Let me try to get you in this upper position." And I said, "Okay, that's fine." And 3,500 people applied for this company. 3,600 people applied, and they narrowed it down. This one position that was the only full time that they had available. That she was like, we need somebody of your experience. It was me and another person. They finally nailed it down to after 5 long, grueling interviews with everybody and their brother. And I was like, well, fuck's sake, what else experience do I have to have? I have 20 years of retail experience. I graduated from nuclear power school. You're telling me in the civilian sector that would be equivalent to a job about $170,000 a year. This job was 40, 45, I think. And I couldn't even get that. So, I mean, it threw me into a tailspin at that point. I was crushed, to be honest with you. I was like, this is just ridiculous. And I kind of lost hope. I'm not going to lie. And that's kind of the reason why I kind of got more in the great debate, because originally it was just to get my mind off things, but now it's turning into a full-time thing. But
well, that's good that it's turning into a full-time thing. But yeah, that's kind of where how good the Navy nuclear training program is you could step out of nuke school, go through the 2 years to the 18 months, go to a ship or a submarine, and then when you get out, either work at a civilian nuclear power plant where you'll probably start at about 85 as an auxiliary operator, which is somebody who operates the equipment, the physical equipment inside the plant, turning valves, doing maintenance. That's not even doing maintenance. It's almost strictly operating the plant. That's about 80 something starting. You could be a reactor operator, which means you're in the control room monitoring the control rods, the reactor itself, reactivity controls and stuff like that. That's about 150,000 a year.
Amazing.
Or you can go into, and this is really this is a weird sector, but data centers, server farms, they love Navy nukes, and they will start you off at high 70s, no degree. All you got to do is be able to do maintenance on the cooling systems, right? Because all these server farms need chill water systems, pumps, fans, ventilation. And
you have to know a lot about heat
ton.
thermodynamics, correct? Like what we studied.
Yeah, and that's it. And they love Navy nukes. They'll pick you up immediately. Wow.
It just kills me. You know what? It never worked for me. Like I said, I got out and I got back into retail because I couldn't really. I worked for a biomass steam plant for a little while, and that was just hard. I mean, it was hard work and it was dirty. And I was like, I'm used to lube oil. Okay, I understand grime, but when you're doing a biomass steam plant, you've never seen the amount of crap that those things have.
I have a buddy who works at a government water purification system or company, and it's regulated by the state, and he's employed by the state of the state he's in, which I don't want to talk about. But he says it is the nastiest stuff he's ever seen.
I can imagine
for water treatment.
So real quick, when people like the clown car posse start talking about the fact that I don't have my degree and I'm not knowledgeable on science, because Ronnie loves to say that all the time. Oh, Steve doesn't know what he's talking about. I mean, as somebody who has gone through the program I have, plus I actually had 2 more years of college after that. Could you explain to like Ronnie and the clown car posse that we had to learn much more science than they would ever possibly?
Yeah. So Steve, if you take a look at if you've got all your transcripts from the Navy, if you go to Thomas Edison University, I think if you take English, they will give you I
took English. I got an A in English.
So go to Thomas Edison University.
I have 120 credits, dude.
There you go.
I took a lot of courses in college after I got out.
But with
I took some I took some from Texas A&M.
But with all of our training, you should be able to get a bachelor's in nuclear engineering technology, like right off the bat.
I've looked into that, but they want you to take some other courses, and I'm like, okay, that's fine, but where the hell you take them from? I mean, I don't know any college that says, okay, let me see your transcripts. You took this and this and this. Okay, pay us this, we'll give you a degree. I've never seen that. If they did, I would love that.
Thomas Edison probably wants you to take a semester of classes, but that's essentially it. Then all of a sudden,
you have fine of doing, by the way.
You have a 4-year bachelor's of science of nuclear engineering technology.
So would you say right now I have the equivalency without that piece of paper of a bachelor's degree in nuclear technology or whatever?
Yes.
I've kind of thought that, and I've said the same thing, but I didn't want to overstate my qualifications.
Now,
so
the difference
them quite a bit.
I would say the difference between a nuclear engineering technology degree and a nuclear engineering degree is the way more in-depth calculus, we went way further in depth with particle interactions and neutron transport theory and simulation. So like I had to do a final project. The final project was actually doing a fuel load for a combustion engineering boiling water reactor. So
well, but the technologies goes a lot more with the instrumentations and things like that nature. And by the way, boiling water reactor, I mean, it was pressurized water reactors, but I could understand that the theory kind of translates over. I mean,
yeah, all the theory transfers over. Some of our innate or the things that we've been drilled in or had drilled into us, a little bit different. So some of our instincts on how reactors should work and how power works. Right, we're always taught reactor power follows steam demand.
Right, on a pressurized water reactor.
Yeah, and that's totally backwards in a BWR.
Yeah, I actually knew that. But that's okay though. That's like, okay, we understand it works for this particular thing in a pressurized water reactor. You're literally beat down that controlled by steam demand, not rod height. But let me ask you this. Let me ask you this quickly. Live chat especially chime in on this. Joe and I actually had a presentation on how a reactor actually worked, how we actually go from the steam generation stage to the steam generators to the condenser to turbine or to the system, which is going to be the shaft and the propeller and all that. Would you guys be interested in something like that? Because I would actually love to do a presentation on that. What happens with the pressurizer? What happens with the steam blanket? What happens with the neutrons in the system, and how you have the change of the K effective, which is your reactivity, change from neutron life cycle to neutron life cycle. Would you guys be interested in that? Would you, Joe?
I wouldn't mind doing stuff like that. I would just be careful of confidentiality issues, but I'm sure we can get around it.
The numbers are what's confidential. The theory is not.
Yeah,
I've seen the theory written in many other places.
You know what I'm interested in? Math hangouts.
Yeah, well, this is physics. I like physics too, but I mean,
well, yeah, that too. I guess that works.
I mean, the confidentially, okay, people may seem to realize that Nuke School, the dark side is classified, and the numbers I think are what's more classified than the theory, because everything I could find sources for theories that are unclassified. Matter of fact, you go to Nuke Facts, it's all there.
Yeah,
all the theories there.
They are starting to declassify some of the things. So on the dark side, they're starting to let students take their notes home.
Wow.
Right? So in Navy nuclear power, we call the dark side is what we call power school, which is 6 months of 3 years of engineering without the calculus.
Isn't it ridiculous? I mean, by the way, Matt Dillahunty was a nuke. Did you know that? But he dropped out. Yeah.
What happened to did he drop out of nuke?
I haven't found out yet. I got to ask Anthony Magnabosco or somebody. Right. I don't know how far in the program he got. I don't think he made it to the dark side. But you're right. Here's the thing: people are going to try to do bulk of this, but I'm telling you right here and now. When Joe said, I think it's more like 2.5 years of college, but okay, let's extend it to 3. You are taking 3 years of college and you're cramming them down into 6 months. This is why you're at school 18 hours a day.
Yeah. Yeah, and so the curriculum is classified too. So you can't take any of the material home, so you can't study at home. So you can only study at the school, where all your stuff is locked up and there's combination locks that are high strength, high security locks for everything.
Yeah, I can understand the secrecy.
But is there any school that you know of in the civilian sector that has that amount of information and paste thrown at you at one time? Because it's ungodly.
No, nothing I experienced in. So I went to Penn State University. Nothing I experienced in Penn State University was as difficult as the sheer amount of material thrown at you. Now
5 level courses in one time, basically. Because you're taking, let's see, in one day would you have metallurgy, would have fluid theory, thermodynamics, which was one class. You would have vector analysis. You would have, well, in my case, mechanical engineering. Yeah, you're a mechanic, so you got to take those courses too. Yep. I wonder if some of the other courses we took.
Like so thermodynamics for engineers, I would say, taking out the calculus, you have what, 2.5 weeks of thermo?
Oh
And
no,
and
it's
that's
longer than that.
maybe 3 weeks, and that's plus you're taking
I
other
would say
courses.
I would say it's about a month total if you take out all the maths.
Okay. But
But
yeah,
I mean,
that's
still we had math. I mean, there was calculus involved. We didn't take it wasn't analytical calculus. It was graphical calculus, but it's still
Yeah.
calculus. I mean, you can't work these systems if you don't understand the time rate of change. It's just not possible.
right. And if you actually do the calculus, you get in trouble by the instructors. You have to do it their way.
Yeah, and which kind of sucked was I took calculus in college, and do you have any idea? You do, but most people have no idea. It's how difficult to go from a graphical based a system
Oh
of learning
yeah.
calculus to analytical. It's not easy. It doesn't
No.
translate as well as you think it does.
No.
But memories, guys. I'm sorry. We're just going off on memory lane here. I hope you guys don't mind. Nobody cares. We put everybody to sleep. That's okay.
Yeah.
No.
Well, I mean, everybody has a little niche they get to talk about, right? I mean, Mel talks about her cancer stuff, and everybody has a biology they talk about. There's one subject that I actually took, and this was nuclear technologies. And so it's awesome to me where I can actually have a conversation with somebody on this topic. So it's the one thing that I could talk about and not feel like a total idiot compared to other people upon, you know? Because I mean, you guys start talking about biology, and I only have a very rudimentary understanding of biology from what I took in college. I mean, I try to wrap my head around it, and I think I do a decent job. But I'm in awe of what somebody like Mel would know. You know, it's like, teach me what.
Yeah, my field isn't in science, so any science.
Hey Mel,
Like,
what you were talking about making detectors. What kind of detectors did you make?
Oh, I didn't I didn't make detectors, but I worked in cancer detection. I have a paper that was recently under peer review, and we got the notes back. And so I'm not with that lab anymore. So they're having to go through. It was a lot of notes. I don't think people understand just how soul crushing peer review is. So I mean, it was
Sure.
like several emails. How do you know it was this and not this thing over here? So I helped engineer a breast cancer test that was a micro device where we implemented both 3D printing. I also molded silicone in the lab. We used nanoparticles that were conjugated with antibodies associated with the cancer we were trying to detect in regards to exosomes. So I worked in cancer detection, and I also worked in computational chemistry. I now work in industry. I just got a job a few weeks ago where I'm working with protein recombination. So essentially, we take in this particular lab works with yeast, and they do DNA recombination to where this yeast will produce antigens associated with a particular virus that's used in detection. So we have a lot of nasty things at this lab, anywhere from HIV to Zika to hepatitis A, hepatitis B. Hepatitis A, I think they do a lot of antigen generation with that. So.
And that's not with the CDC?
No, it's not with the CDC. It's an industry position.
Wow.
So I'm working in the protein recombination. So essentially, my job will be to take yeast cells, infect them with various viral genetic code, and have those cells manifest the proteins that we want in regards to various antigens for detection. So I think the latest order we have is for HIV2,
Okay.
the GP36 gene.
So is that the same way that they create, like, because so they were talking about having the Zika vaccine or a Zika treatment? Is that the same way that they make that, or
they are, the company I'm with is moving away from vaccines, but they are working more on the detection aspect of things. But they do, I mean, vaccines are usually made within eggs. And so, because they're all egg based. So they'll inject a various virus in there, and they'll have deactivated forms of the virus that they use, and that's what they put in vaccines. They're not active forms of the virus. They're dead forms of the virus. So, but that might be it. But I came on, like I said, just 2 weeks ago. But I have a whole lab to myself, and it's nice, and it's fun, and I'm like all scienced out. I'm like, woohoo! I get to do column chromatography, and then we run the spec. I'm just happy as a clam. Yeah, you know. It's funny. They provide scrubs. We have to wear scrubs when we're there, and so they provide the scrubs there. You don't want to take that stuff home with you. So.
Yeah, infectious diseases and radiation, two things to probably minimize exposure to.
Yeah, you leave your work at your job.
Yeah, it's funny because you know, I was talking about Joe earlier. He was a control point access engineer. Basically, what we did was when you have a spill or something, you have to set up a very you have to set up a parameter, right? So you don't get contamination across in other parts of the ship. I mean, it's a control point, and you are God at that point. Nobody enters that space and you allow them to. It doesn't matter if they're the president of the United States; they don't fucking go in. Period. Oh God, I totally lost my train of thought on this. Sorry. I got
to piggyback on that, right? So we were talking about welds before. We do radiography of welds, and that is taking X-ray of welds. So obviously, you need a very, very, very potent source to do X-rays of stainless steel to see the welds and make sure they're perfect and take multiple shots. I mean, we were talking like 1,600 rem an hour or something like that, an inch away from some of these sources. So, right, you are God when you're in charge of these things, because basically, if somebody walks in front of it, just the time of them going, "Oh shit," and then walking away, they will probably die. So
yeah, that's what I was kind of going at. Is that you have to understand the time, the metrics to go into that, the distance that you have from the source, the shielding you have between you and the source, the time of exposure, and there's other things that get into complexity. If Joe remembers, remember you have the plane source, line source, and point source.
Yep, and then you also run into things like biological half-lives, especially because I took Radiation Health 420, and that was all about how different radioisotopes end up in the bloodstream or the liver, the lungs, and how if they end up inside different organs, they can give different organs, other organs, doses. But some of the organs are less resistant to dose than others, and it becomes this gigantic mess.
Is that more the quality factor? Because I remember the quality factor for like beta.
Yeah, quality factor is a very simple way of trying to understand how gamma, how photon energy, how electron energy, and how alpha or neutron energy affects the body. This is like if I breathe in cesium or xenon 135, it could decay in the lungs, but if it decays in the lungs and then becomes the particulate cesium, it gets transferred through the bloodstream, but that likes to end up in bones. Specifically, it likes to end up, I'll just make up something, like the small of the back. Well, if it ends up in the small of the back, it likes to give your lungs, your kidneys, and then your liver dose over the course of the time that it's inside your body.
Is a lot of that based upon like water content of the organ?
Some of it is based on water content. Some of it are, right, your bones love anything with the electrochemistry of calcium. That's why strontium is real bad.
Right, I remember that. Iodine goes to the thyroid, strontium goes to the bones. And
yeah.
like the heavy, some of the heavier nuclei would be like 20 times worse as a Q than gamma rays or something. That's a lot of biological damage, because usually you have an ionization potential that's causing dissociation of the water, but you also have direct DNA damage that can be caused as well. And these heavy isotopes that are highly ionized, like the He+2, which would be your alpha particle, does a massive amount of damage to the body.
Mm-hmm.
If you ingest
I was wondering if you read about the human plutonium injection experiments?
No, and I don't think I really want to be a part of
Oh,
that.
wow. So in the 50s, they tried to figure out, because, right, they had all these emerging factories of creating plutonium, right? We had Oak Ridge. We've got the place in Washington, which just went out for my brain.
I know the Lawrence Livermore Laboratory.
Yeah, so there's there, but the Hanford site. Hanford's huge. Yeah. So between them, they're industrial facilities to create
Demon Core.
Yeah, to create radioactive materials and fuel for bomb projects and whatever. Well, they actually didn't understand what plutonium does to the body. So the government, this kind of sounds messed up, the government injected people with it.
Wow.
They had a little boy from Australia come to the United States for cancer treatment in the late 40s, early 50s, and what they did was they shot him up with plutonium and they watched him die.
Wow. Yeah.
And I mean, this is how they help save other people in the industry. But this is what they did.
The ethics of that alone. Plutonium is one of the deadliest substances known to man. If you look at the radiation of it, I mean, I think it's a millionth of a gram in your lung will kill you. It doesn't take a lot.
You know what I'm surprised about is
That's why people mistrust the government. Just saying.
Yeah, there was a guy who went in for a stomach ulcer. So the idea behind this project is they were going to inject people who were terminally ill. Well, this guy wasn't terminally ill. He just had a stomach ulcer. They thought he
was now.
No, he lived for another 45 years. He got an overall dose of 970 rem.
That's about half a chance of survival. That's about 50% death rate.
Yeah, but he got it spread over a long time. He had no adverse effects from it, none whatsoever.
Yeah, if you get exposed to about 1,000 rem, you have about a 50% chance of dying.
I think it's 600 rem is 50%. I think 1,000 is 90%.
Is it that? I remember being 1,500 or 50%, but it could be right. So maybe it's down low 600. I don't look at the. Well, I guess. Well, it wouldn't depend on the type of radiation because you're talking about rem, so it's the Rankton equivalent, man. But I would have to look at the numbers. I remember the actuary charts for that, and I can tell you right now, if you get exposed to 1,000 rem, your chances are not good, though.
Yeah, you will probably die. In not quickly, but very, very painfully.
And what happens is mostly your intestines fall apart because your intestines have a lot of water in it, and so you get a lot of disassociation in the cell itself. The water will form hydronium and hydroxyl ions, and the cell dies, and so your intestines literally fall apart because the cells are dying. That's a hell of a way to go.
There's that. Your immune system becomes incapable of fighting off anything. Yeah, it's a mess.
I'm gonna have to see if there's. Yeah, let me see if I can find actuary channels charts on that at some point. I'm kind of curious what it was because I remember. Do you remember the SL1 accident, the Army reactor?
Yes. Yeah.
That was the guy that actually pulled out the rod. And for the guys in the live chat that may not remember this, which is pretty much none of you because this was hushed up for a while, I think. There was a reactor accident called SL1, which was a Army reactor, and the way they control the rod height, which is basically these rods that go in and out of the core, they're usually made of a boron or some kind of doping thing where it absorbs neutrons so that your fuel doesn't absorb it. And the way they controlled it was not how they controlled it like in my plant. We had what's called control rod drive mechanisms. They were basically these magnets that had screws that went in the middle, and as it rotated around, the magnets would rotate around, the shaft would be moving up or down. Nothing sexual there, it's just what it was. And that would actually raise or control the rod height, and that would adjust the reactivity in the core. Well, in their system, the SL1 system, somebody actually had to go and physically stand over this control rod and pull it out. Not a great design, in my opinion, right? And what happened was they were only supposed to raise it a few centimeters at best because it doesn't take a lot to add reactivity to the core at operating conditions when you're above what's called the point of adding heat. And please, Average Joe, correct me if I say anything wrong here. I'm going back 25 years here. But the reactivity addition rate is very, very great after the initial transit when you raise rod height. Well, he rose it like several inches, way more than what he should have. And there was a flashover. There was basically the water in the system flashed to steam. Well, steam takes a bigger volume than water does, and it ejected the rod through him and pinned him to the ceiling. He died instantaneously.
Jesus.
The people in the control room, which was two, there's 3 total at the plant, they were exposed to, I believe, about 1,000 to 3,000 or something like that Raman contact. They didn't survive that. They were not going to survive that. But do you remember learning about that particular reactor accident, right, Joe?
Yes.
Yeah.
Yes, quite a bit. So I think they had a little bit more information when I went through. A lot of it has to do with the Army's quality control program, and then a lot of the training that the Army got was substandard compared to anything that the Navy got, and it has to do with some cultural differences. I think you guys were talking about before, like this anti-authority, kind of like this anti-confirmation, or this like confirmation bias system. But the Army really resented what the Navy had, which was a culture of, we're going to take these people and we're going to train them and give them, 200% of the knowledge they need in order to operate this thing. And the Army took it as, what the Army does, which is
bare basics
for you guys to be able to do it. Also, I'm in charge and do what I say. Whereas the Navy's philosophy was, hey, we're working on a $1 billion reactor. Even though I am in a position of authority, if I tell you something, or if I tell you to do something that will break the reactor, I expect you to defy the order and tell me that I'm wrong. And
I had to do that once, Joe.
I had to do it twice, and I won. I won one of the issues, and I lost the second one.
I won one. The chief engineer was like, "Okay, you're right. Move on." That's all it was. It was literally as much as that. Go talk to the Chang. I explained the situation. I was like, this under this operating condition at this temperature, this pressure, I was not. You cannot, by standard procedure, have this amount of this alignment of the pumps running. It says it right here, black and white. Do not do ever. Right. And that's if you're going to make your case, then you're good. You're golden. Right.
Yeah. And even if you bring up reactor safety concerns and you're wrong, nothing happens to you, which is different than the Army. And that's
well, you get laughed at a little bit, but
you get told to shut up, private, and go do your job.
Yeah.
And I guess what happened here is the rod got stuck when they were pulling it out, and when it finally jerked free, because he had to use extra muscle on it, it jerked free. Then we had supercriticality, and it went prompt critical, which you guys can look up. Very dangerous condition, and all the water.
I can explain it.
I mean, you could, but I
love this stuff, Joe. I don't get a chance to talk about this stuff often. I know what prompt and source criticality is. Prompt criticality is when you had criticality from the neutrons that are coming from the initial fissions rather than from the delayed neutron precursors.
Right.
Take that, clown car posse. Shove it. Sorry, I had a lot of coffee and I really like this topic.
Yeah, it's not where you want to operate a reactor because it's explosive.
Yeah, the prompt. Well, I remember doing startup rate or doing startup, and the worst place to have like a partial coolant accident or even a cold water accident was when you're at prompt criticality initially. You're just relying off the source neutrons. The fission fragments, you take time to decay. Obviously, you have a delayed neutrons, right, from the delayed neutron precursors, and that hasn't kicked in yet. And so when you're at the point, you're not quite at the point of adding heat where you actually have the temperature elevation go up. If you had a cold water accident at that point, I remember that being like the most worst thing that I could ever imagine, because now you have so much reactivity out of that core because you have cold water going in, which is dense. You have a mean free path that's very small, meaning that neutrons going through it are going to be thermalized or slow down very quickly. And those are going to be absorbed very rapidly by the fuel, which is uranium, who likes to absorb slow neutrons. And so you basically have, as you said, this massive supercriticality that water is going to flash to steam, and you just boom.
And then the other thing is, right, usually water, as it heats up, slows down the reaction. But at those low reactor powers, and below the point of adding heat, water can't change temperature fast enough.
Right.
So
it has a negligible amount because the negative temperature coefficient of reactivity was such that as the water would heat up and become less dense, your mean free path through it is greater. Therefore, you have neutrons that are not going to be thermalized as much. But at the point before the pointing about a heat, you have some more criticality adding to know that what that is the water density is affecting it. So basically, that negative temperature coefficient of reactivity isn't having a greater effect than the prompt neutrons.
So,
wow,
so
I really actually surprised that I kind of remember this shit, to be honest with you.
If you want to see something cool, I would take a look, go on YouTube and look up Penn State Reactor Pulse. That is Penn State's reactor, which so Penn State University has a small reactor. It goes prompt critical, and it saves itself.
Wow. Yeah, I'll have to check it
out.
No,
it doesn't need rods. It doesn't. So the trigger reactor is designed to go into space. And it was designed in such a way that it would never need operator action, which is scramming, or it was made in such a way that even past Saturn, it wouldn't need rods to save the reactor.
And that's so counterintuitive than what I remember, because obviously we're ingrained with this stuff that on a pressurized water reactor, prompt criticality is a very bad thing.
Now, no, don't get me wrong. Prompt criticality on a trigger reactor is still bad, but it won't have any damage whatsoever, and that has to do with it's zirconium hydride fuel, and the hydrides upscatter. So, like usually we thermalize, but the zirconium hydride fuel gets so hot that the hydrides in it upscatter the neutrons out of the fuel absorption resonances.
And I actually understand that's
and it shuts itself down.
We had zirconium, but that was the plating, the clay,
yeah. So we use so you probably use Zirc 2.
It was Zirc 2 oxide, I believe.
Yep.
And that was the clating that was used to not just hold the fuel in, but it actually acts as the thermal conductor. It actually does a lot of things that clating does.
As the clad, yep.
Yeah, the cladding. And let's see here. What you were saying before, the Barn rate, if I remember this, and again, I am pulling this out of my head, people. The Barn ratio was such that if you have a specific resonance of the neutron, because the neutron's coming out, you have the two types of neutrons. You have the one that's being produced through the actual fission. That's going to be 2 to 3 neutrons on the average. I think it's 2.4 for uranium-235. And then you have the ones coming off the fission fragments. But if they're going to be at a certain resonant frequency, that the target area for a new uranium-235 presents it such that it's called a Barn ratio. And it's saying, okay, if I'm in this specific window of resonance, the uranium is more likely to absorb it than not. And I think if I remember correctly, the resonant escape probability.
Right. Well, the resonance escape probability was the probability that a neutron would escape resonance capture by a poison.
Oh, by boron or something. Okay.
Boron is xenon. And again, I'm sorry to everyone else in here.
We're boring the shit out of them, but I don't care at this point.
We are nerding out. But usually, you guys
talk about this stuff.
God damn it!
You guys are talking about,
yeah, I have listened to them talk about
keys and stuff, and I have no idea
by it. But this is the first time I've actually been able to talk about nuclear kinematics and stuff like that with somebody who understands it, because I don't ever get a chance to talk about this stuff. No, very rarely do you guys hear me talk about this stuff unless I'm drunk. So I'm thrilled to death to talk about it. Dude, I put a lot of effort in studying this shit at one time.
So there's no hate here. There's no hate here.
Good. No hate. But I'm going to get another cup of coffee.
You do what you gotta do.
Are you learning anything by this, or everything we just said made no sense? Probably.
No, I can follow you guys. I am intelligent. I can't understand words.
Well, he speaks. Here's the thing.
Understand words.
We often jump into I think
he speaks the language I understand, right?
Yeah.
This is what we're talking about when we're like reading papers and stuff like that. And you're saying, "Oh, look, here's a paper on genetics." You have to understand a little about genetics to understand the paper because of the language being used. Mm-hmm. He's speaking a language I understand.
Well, I understand you guys are fond of rods, and I get that.
We love rods.
Oh yeah, I like doing the fast insertion.
Oh, I remember fast insertion. Yeah.
And that
That's
was
a
a guild
that's
guy,
a
right?
safety function. Yeah.
Yeah. Well, Scram.
But yeah, so Scram is the immediate one, which is funny because in the civilian industry, Scrams are like 15 seconds instead of instantaneous.
Scram in a Scram in my plant was less than a second.
Yeah.
If I
Well,
remember, it was pretty damn
so
quick.
so BWRs insert the rods from the bottom instead of the top.
Oh, I didn't know that. Really?
Yeah.
I thought
yeah,
because
it's
ours was
totally
gravity
different.
dropped. Because once
Um,
the CRDMs opened up, it released the metal shaft in the middle, and then they just fell down under their own weight. But it was pretty quick. There might have been a spring in there too, if I remember. or
There was a
something.
spring in there. Yep.
Okay. Yeah, that's right. There was that spring. I remember that spring in there. That actually held the excuse me, a lot of the energy. So when it scrammed, it released and was able to push them down. Wow.
So they had video of because we had these newfangled control drive mechanisms, and they had these really cool like super slow-mo iPhone. They weren't iPhone video, but that's what it looked like of the spring pushing the control rod to the bottom of the core and watching the control rod bounce off the top of bounce off the bottom of the vessel. Not the bottom of the vessel, but the bottom of the rod tube. It's really cool to watch it at, super slow-mo. I don't know. I think I nerded out too much.
Broke the internet.
Is that even possible?
I'm sorry,
What's that?
I got back the very tail end of that. What'd you say, Joe?
Yeah. I said we had this super slow motion video of the spring letting go of the lead screw on the control drive mechanism and driving it to the bottom of the core, and then watching the whole assembly hit the bottom and then bounce very slightly off the bottom while the whole rod is wiggling. It was super cool to watch.
Yeah, see, but we didn't do that often because obviously that put a lot of stress on that system.
Yeah.
You have to test it occasionally. But I tell you, I've scrammed the reactor before. And the feeling you have, you're like, I've just shut down a 150 megawatt reactor in pretty much less than a second. And I mean, shut it down. It doesn't require, starting it up takes hours. Literally, it takes hours long procedures because you're mostly dealing with temperatures and pressures, and you don't want to have like brittle fracture. You don't want to have this pipes explode. You have to warm things up. You have a curve you have to follow. You have xenon levels you have to deal with. There's a whole bunch of different factors going and starting up a reactor. But shutting it down, you're done. It's one thing. And usually, and on our ship, I don't know how you did it on yours. There's a couple ways to scram it, but the most easiest way for us is you actually release the pressure on the ship's turbine generator, the oil pressure. And that drop of oil pressure causes it to shut down. You wouldn't think they're related, but they're directly related to each other. If the ship's turbine generator shut down, that caused the CRDMs to release.
Nope, they got rid of that. That's not a thing.
Old school. Well, yeah, dude, I was in the Navy from 87 to 93. I'm sure technology has changed since then, but
yeah, no, it has. It's way different, which is weird. It's weird because when I joined the Navy, they told us all the technology was going to be 50 years behind. So I get to a new Virginia class submarine, which was the keel was laid in 2004 or something like that. It's brand new. I got to it just after Bravo trials in 2007, which is brand new, and that thing is light years ahead of the civilian industry.
Oh, I was on a piece of I was on a frigate almost. I mean, yeah, no, it was a destroyer, but still, it was this old school. It was held together by duct tape and string.
Oh yeah, no, we got rid of motor generators. It's all variable frequency drives and LCD screens, and there's touch screens and
no, shut up. That's just killing me now.
I mean, like a lot of people call, especially the forward end of the submarine, they called it Star Trek because like a lot of the guys they've got these touch screen displays, and all they do is they put in the course and heading, and they just type it in. Like, hey, make your heading 020 speed, 15 knots, 30. Make your depth 200 feet. Right? You just plug it in. You just type it in, and boop.
But you still have to know all the same stuff we had to study for that. Wow.
Yes.
So let's ask Lachi, or you guys in here. I mean, you guys have any questions on nuclear reactors? Because I want to do a presentation on this. I think that'll be fun. I'll explain how it works basically.
It is a shame that King Crocoduck left. I would have loved to hear a little bit more about Pilot Wave from somebody who's
he didn't know much about Pilot Wave. That was the problem. Yeah, he knew about Bell, but he never really looked into De Broglie bomb. And I would have liked to too. I'm going to find somebody that knows more about it. We're going to have another hangout on it because I think pilot wave theory makes a lot of sense, but unfortunately, it just doesn't work across the board. It doesn't work because of local realism. It doesn't have locality. So I mean, and it does add more stuff. It's not parsimonious, by the way.
Yeah, there are reasons why Copenhagen theory obviously won out, but I think the biggest reason is because of the Manhattan Project, and that we pushed one interpretation that could prove or could produce results good enough to make a bomb and drop it on people.
Yeah,
and a lot of the physics got geared that way, and then right after we got dropped the bomb, we made the hydrogen bomb. While on the flip side, we were building civilian nuclear power to build Navy nuclear power, and we just kind of went with something that was good enough. And I always think of Copenhagen as a good enough instead of what is actually true.
And it's kind of amazing that
we got so far with it, but like it doesn't explain things to an accuracy that we need to really develop quantum interpretations of things further. You know, we can say that alpha particles tunnel out of heavy elements, but Copenhagen doesn't explain anything on why.
Well, two things. One, the stuff we learned actually will translate into weapons, fissional weapons. I've seen a lot of the theory for fissional weapons. It's very, very similar. Once you start getting into fusion and Yuri Teller designs and fission bombs, it's completely different. The formulas used for fusion yields are just mind-bogglingly complicated. I don't think more than 5 people in the world probably understand them. They're that complicated. So there's a distinct difference. But for fission, what we learned is basically how to make a nuclear bomb that way. I mean, a simple fission bomb is not that complicated mathematically as far as the formulas. I mean, there's some technical things when it comes into providing a reflective temper to kind of get more of a yield out of it. But the basic principle behind a nuclear bomb is pretty simple. But when you're talking about the Copenhagen thing, it is it's pretty simplistic. But there's other things that go into that. But excuse me, I'm sorry. Oh my God, I was going to mute and I didn't get a chance to. My bad. Sorry about that, guys. I went to go mute it and I couldn't reach it in time. But the Copenhagen, the problem that we run into is that no matter what interpretation you take, not one yet explains these things on a gravitational level, nor does it explain it when you're dealing with relativity. Matter of fact, the pilot wave theory doesn't work with relativity. The Copenhagen doesn't work with gravity. There's a lot of things now additional you've got to have. So that's why they get into quantum loop gravity and things of that nature. But as of right now, the Copenhagen only works on a very superficial level compared to what you would have to explain certain systems like black holes or I don't know what other systems would. I mean, any kind of quantum system where you're dealing with gravity, shit just breaks down. So,
yeah, and I don't really know what to make of that. And
well, because we don't know much about how this stuff works. Quantum mechanics is so confusing that it's so counterintuitive to what you would think of things from a classical point of view. And then you're dealing with gravity; it just throws in all these other things that if you want to describe the system, you need a lot of mathematics.
Yeah, and I've got a buddy who works at Intel, and they're doing transistors, so NP junctions and composite and wafers and stuff like that, and they find that
that'd be a diode, but yeah.
Yeah, sorry.
NPN.
But they find that they start getting quantum tunneling on how small the chipsets are getting. And we understand that electrons leak out, but
Well,
we can't really compensate for it because we don't. I mean,
actually, kind of, yeah. Matter of fact, they used to have the limit for the smallest amount of transistor size or amount of compacting transistors on a wafer. I think it was like the scale was like 13 nanometers.
yeah.
So that what they thought was an actual limit. But I just read something recently where now they're using by using nanotubes, that they can actually reduce some of the electron tunneling that's inherent in a quantum mechanical system and a transistor, and they can actually get it down to about 8 microns now.
Wow.
So
yeah,
that limit that they said is a hard limit, we can never get past this. Now they can actually get past that by using more modern technology, which is amazing because that was a threat. That was considered to be a hard threshold for a long time of how much transistors they get on a single wafer.
Yeah.
Because of that very reason, because you have those quantum mechanical effects.
It was a physical limitation.
They thought so, but then they found these nanotubes will actually limit some of those quantum mechanical things.
It's the old story of something's only impossible until it isn't.
I think so. I think that when you get into the stuff like quantum, I hate when people say, "Oh, it has to be this way. There's no other possibility." Yeah, you know what? I don't really say that anymore. I say it's more likely. Like, for example, I don't believe in time travel backwards. I think it's probably highly improbable, but it's not. I can't say it's impossible.
Well, the question is, we don't know what happens if you could. Do you go back to a different, are you eventually going to another universe rather than our own?
It depends on that goes directly to the multi-world hypothesis as opposed to the Copenhagen interpretation. Yeah. So.
Yeah. By the way, I was listening to you talking about reactors. Have you seen the difference with the new reactor for the Gerald Ford class?
So I have a buddy who works there and worked on the Gerald Ford.
Yeah, it's the A1B, and apparently it's got 25% increase on the A4W.
Which A4W, the Nimitz class. So yeah, that.
Who makes that?
This one, Bechtel.
What's the B stand for? What?
Bechtel.
Bechtel?
Yeah.
Yeah, I don't know who they are.
Bechtel builds
like A4W, A5W.
Yeah, so Westinghouse makes the core, but Bechtel makes all the machinery and stuff like that. So Westinghouse might make the core, but Bechtel builds the vessel pressurizer, and a lot of the other stuff. But now, what's that?
A1B, they don't name it after the core. Like A1B would be aircraft first generation Bechtel.
Yeah, so Bechtel is they're always named after the core, but these new ones are actually produced and manufactured by Bechtel. So
interesting.
Yeah, Bechtel's gotten into the game. It is a brand new class. I know some stuff about it. They've reduced a lot of the piping and they simplified the plant. And supposedly they've reduced manpower or needed manpower by 20% or more.
Is it that automated?
Yes.
You know what a big function of what we did was basically, I swear to God, I'm not even lying. The reason why you had a human component was only because we had to go take readings of this stuff. You would go around, you would take logs, and you would look at the value, the gauge or the readout, whatever you have, and you would write it down. That was your job.
I have seen designs for the Boomer class that may only have 2 engine room watchstanders.
Wow, that's
two people in maneuvering, 2 people in the engineering, 2 people in the engineering space. That includes the engineering watch supervisor.
We had, well, if you include the supervisor, which I was, you could get away with 6 watch stations in mine, I think.
You heard about the boat that started up with 3 people, right?
There's no way 3 people could start my ship. Not in the.
Yeah. So a group of people started up a U.S. Navy submarine with 3 people, and the way they found out was they went to do a startup later, and they had more xenon in the core than they expected, which means that rod height or the amount that they would have to pull rods out in order to start the reactor was off, which means they shut down. And after doing the investigation, they found out that people had an unauthorized startup of a reactor that they did with way less people than you probably should have.
Let me translate that quick. What happens after a shutdown? You have some decay products being produced. One of them is called xenon, and xenon is a neutron absorption thing. It actually likes to absorb neutrons, and you want the neutrons to go in the fuel, obviously. So after a shutdown, you have this huge spike in xenon, and so you have to actually wait for xenon to start decaying, and you have these decay curves. You have these big old long formulas you have to work out. They're not easy, but these decay curves will tell you at this specific time, this is how long you have to wait to raise rod height enough to overcome the negative reactivity added by the xenon. And if you try to start a reactor up initially after a shutdown like that, so you have this huge spike in xenon, I could even imagine how high you would have to raise rod height to overcome that. It'd be ridiculous. And Sam, Mel, no, you can't take off. No, you're stuck here. You're stuck. I have to listen to your biology stuff. You have to listen.
Run, Mel, run.
I'm kidding. Mel's like, I'm not ever doing this again. Nope.
No, it's not that. It's just it's dinner time where I'm at. And, I actually, right before I hopped on here, just finished working out. And that's why I was late, because I was in the woods doing my free weights.
Awesome. Well, thank you for letting me nerd out, though. Again, I don't get a chance to talk about this often, so I'm just in heaven here.
That's quite all right. It was fun.
What is agnostic heaven like, Steve?
You know what? I'm going to be suspending judgment on that.
It's probably got a lot of cheese and,
tequila.
Maybe some really nice whiskey.
Cheese and tequila. That's my
I need to know, Steve, how many polls is it going to require to answer that question?
I don't know. I think they're going poll crazy.
Yeah.
Well, we're gonna rein it back a little bit in 2018. I'm kind of like not being too harsh on some of the stuff, but we got to start implementing some rules here in 2018. I think people when you get three posts of the same thing, or you have posts that have no commentary, that's not what the GDC is supposed to be about. Now, I do got to tell you, there's been some criticism about like adding DFOTY. I don't want to say the whole thing because the deflagging, or excuse me, the demonetization. I'm trying to see if I can get a video that's not demonetized for a change. But the GDC is part of satire. The GDC does mock certain things, and I've read what Tommy had to say. I've read what True had to say on it. I'm sorry, I'm not buying into any of their BS. I'm just not. They're saying some stuff that's not only stupid but dangerous, and I think Mel would agree. Sometimes you just got to mock that level of stupidity. It's not harassment. It's not bullying. And if somebody like Tommy said, "Hey, look, you know what? I'm having this affect me," and like Red said, "Look, Tom, if you want to take off for a month, and I say it's to be longer, and you just want to get your S together, that's fine." And you know what? I would be happy to remove him from the contest. I don't want to pick on somebody who has mental problems, who's being affected by this mentally. I don't want to. But if somebody's going to put out ideas like tumors are good for you and they're sponges that suck up toxins, yeah, I'm going to make that come to light and make fun of that, because that's just freaking stupid and that does affect people. So when you're on the internet, you guess what? Mockery is a part of the internet here. There's no safe zone here. Would you agree? Anybody? Would not agree. I mean, if you don't agree with me, that's fine. I'm happy to listen to your argument. But I don't think that the GDC should be a safe space. And I think that if Tommy puts posts up there where he's saying things like, tumors are good for you or they soak up toxins, then yeah, I think we have a right. Not only that, an obligation, especially people like Mel have an obligation.
I think if there's a dialogue that's associated with inherently harming individuals, then that needs to be addressed. So for instance, I've actually been I say battling, but I've had people in my ads on Twitter for 3 days now over an article that I wrote saying that Twitter and Facebook are not venues protected by free speech. They're not. They're privately funded by corporations. And people are like, well, I'm entitled to this. They're treating it like it's a utility. And my association is that this is like the cafe where the owner throws you out if you're causing problems for the customers. That's essentially kind of what it is. And I can't get it across to people that unless you have your own space where you get to dictate the rules, whoever is the owner of that space gets to make the rules, and you can either like it or not. So.
Yeah, no, I know. And look, I obviously I am the person that has to make the call in the community itself, the GDC G plus community. What gets posted, what doesn't, what's the rules. I have to make the final calls on it. I get that, but
and so, but see, that's something that's what you're dictating because you are in charge of that space. For people who come at me, they're like, well, you know, we should be, and I agree, we need to be able to listen to problematic speech so we can say, hey, you know, that's a problem. Why are you thinking this way? You're entirely wrong. And this is exactly.
Now, where do you draw the line? When somebody says that chemo, you shouldn't get chemo, where do you draw the line?
I call out bad science all the time on my Twitter account. I'm like, this is incorrect. This is predatory. This is why, and I point out why it's wrong. I don't get ugly necessarily, and I don't really.
You don't want to see
names or anything.
Yeah. You don't want to see Mel get that.
I pull out my graphs and I get my data, and I will destroy you with evidence.
Yeah.
This is why you're wrong.
I've done the same thing on Twitter. I mean, to the point that I got so sick of repeating myself, I just created some pictures so that I could just. You know,
it's easier.
I have that. I have a slide that I show. It's like, "Hello, troll. Welcome to my page. Reasons why I'm not engaging with you." And there's literally bullets of everything.
And I made a page like that because of you, Mel.
I mean, I really did. It just saves time, man. It really does.
But it's almost like you see the same thing again and again, and it's like, you know, could you imagine? Let's take the atheism one, you know, or you know, religion is a mental illness. That kind of thing. It's like, oh, for crying out loud, that again? Okay, boomph. There's a picture. There you go. That was that.
Certain chestnuts that are just prats, right? But I mean, don't you guys wish though they would come in, like for example, this particular hangout? I would have loved for any one of them to come in and say, "Hey, Steve, you know what? I really am a fan of the multi-world hypothesis, and let me explain to you why." Or I really think that the pilot wave theory is a better model, and it satisfies Bell inequality, and let me tell you why. I am happy to have those kinds of discussions. Those are things that actually are worth talking about in science. But to have a discussion where they're like, cancer is good for you or not, I can't do that. I just can't.
You know, it just shows a fundamental lack of understanding of what cancer actually is. And it just, sometimes things hurt my brain. And I'm very polite on the internet. And I just say, look, I'm not, at some points, I just have to say, I'm not here for you. And once the argument becomes circular or rude, I just leave it because there's no point. But I do point out, this is what you said. This is why it's wrong. I'm not going to repeat myself anymore. You've not read anything I've sent you. You have absolutely no interest in learning anything. So bye now.
No, seriously, that is why I don't bother with somebody like Ronnie any longer. Ronnie sits on his couch and pontificates on whatever and says how wrong I am and I'm dishonest and that you know, the whole community is against me. And I'm like, Ronnie, I don't think you've really been paying attention. I get corrected like anybody else. I've made my scientific errors like anybody else. I've made other mistakes. You know, you learn. Okay, but that's the difference. I've never seen Ronnie accept a criticism. I've never seen Ronnie be corrected on anything. He's never changed his position and said, "Oh shit, yeah, that was wrong." If you have not once said you've been wrong in the GDC, something is not quite right with you, because we all are. Even Hogtie has been corrected on some things. Right? He's probably the most brilliant guy I know. We all have to be corrected on things. You cannot be right all the time. What you have to be is more right than wrong, at least, though. And that's one thing that they don't have.
Well, you know, I just get often like recently, for over 2 days, I had somebody in my apps telling me how the Google guy was not sexist. He used bad science. He broke Google policies, and he said, well, there was, you know, fortunately a lot of people in Google thought he shouldn't have been fired. I said, are you referring to this particular article that had a chat app where they used to get their data in regards to surveys?
I'm like, I thought it was completely inappropriate from a business point of view.
You know, but he had HR training. I mean, and so he's like, well, free speech. And I'm like,
that's not what
Google's not paying people for their personal opinions, first of all.
Yeah, what's funny, Mel, is I actually agreed with, I'm not going to lie, there's certain things he said in that, and I read it, I kind of agreed with him upon. But I'm like, dude, this is the wrong form for this. This is not the way to go put this information out there. And the way you expressed it was pretty bad.
Well, then he went there and he went and had an interview, I believe, with The Guardian. And he said essentially, well, I'm going to blame my autism for that. And I'm sitting there going, you know what? You know what? And I just about came out of my skin. And I went on a massive rant on Twitter about that.
That's
and
ridiculous.
He's on the spectrum. And so he has issues with social stuff. But when you get to a certain age where you know you have a therapist and you know that you don't understand social cues, before you do something that's potentially damaging to your career, you go to somebody else and say, hey, what do you think about this? Do you think this is a good idea? If you're not certain, he did that. He didn't do that.
As someone who is on the spectrum, I got Asperger's. You know, sometimes the problem with for my Asperger's in particular, I have bad mouth breaks. What goes through my head tends to fall out of my mouth.
Yeah, but that's a sudden on-site thing. That's not a well-calculated, thought-out plan to write an entire manifesto and then send it on a whim. You're talking about a faux pas, a one-time social faux pas. I'm like, oh, I said the wrong thing. Well, that's
more recoverable. Yeah, that's much more recoverable. Sure.
But to sit here and write a giant freaking manifesto and have thought out it.
The thing you were saying about free speech, it does make me chuckle because, you know, and I see, as you mentioned earlier, Twitter, you know, I see it all the time, whether it's under YouTube comments or on Twitter or something. It's like free speech. It is, you know, and they try to think that the First Amendment applies to them. And it's like, you dumb idiot. The First Amendment is just the government can't stop you from saying what you think.
Exactly.
But what it doesn't protect you from is the consequences of saying something stupid, writing something stupid, etc., etc.
Exactly. And I can't get people to understand that. I wrote an article clarifying it and how it is important for us to listen to problematic speech. But at the same time, we are not required to give it a platform. We don't have to give it a voice. We don't even have to listen to it. We can say, you know, go out in the middle of the street and holler all you want, but I ain't got to hear your junk.
Yeah. There's two main takeaways from this. One, obviously, people need to be held accountable for when they say incredibly things. I fully I believe that. And the other thing is, like you said, I don't have to give them a platform. I think that somebody wants to argue positions such as cancer is good, or that you can rape your wife even if you're married, or if you want to say slavery is good. I don't want to give that kind of stuff a platform. I just don't. Those to me are not something I want to have discussion with. I just honestly don't think that those are up for discussion. And if you want to do it, they want to do it on their channel, whatever.
Well, see,
that doesn't mean I have to go on mine. I'm not stifling free speech by that, am I, Mel?
No, you're not. And the thing is I'm very vocal about this. I've done a few podcast episodes in addition to writing articles about why are we giving science deniers a platform. You know, when you have somebody on the news or in media who are saying, well, climate change, you know, humans didn't cause that. Well, and then they have a scientist who says, well, yes, they did. If you're going to actually have an accurate representation of what we're looking at in media, you might have the one person who says climate science is bunk. Then you need about 99 scientists on the same news show saying, okay, you're the one person. Answer to all of these 99 scientists who disagree with you. They're going to ask you questions and you need to be able to answer them. That is what I feel is equal representation when we're dealing with science deniers. But we don't, and I know in the UK, in the BBC, they try to see both sides. But it's like, if you have a flat earther on a news show, they would never, I don't know that I've never seen a BBC News thing where they've had a flat earther on there because it's absolutely ridiculous. But you know, it's either like 2 + 2 is 4. It's just there's just some things that are factual and things that are not. So why are they being given any kind of airtime?
Well, here's the thing.
We actually have the opposite thing. We, you know, a year ago with the Brexit thing that was starting up, and
I landed the day that vote came out. Man,
we should just ignore the experts. And he got ridiculed for it heavily.
Well, just because you're giving, like, for example, when I have somebody on, like a flat earther, or I have Hoven on, it's not that I'm giving them a platform to spew their crap. We are mocking them in some ways. I mean, let's not make any bones about it. There's no flat earther that's ever come on this channel, and I'm going to take them seriously. just not going to happen. I'll tell them straight out
They
there.
quit talking to me on Twitter. They don't even approach me anymore.
And you're the nice one. So how do you think they really interact with you? I don't invite them on to go, okay, you have a valid theory. Let's just check it out, right? I know they don't. It's not going to happen. And when it comes to the Hovind thing, look, I know that there's a legitimate concern that you're giving him a platform, but I looked at it this way. There was more damage by not giving a platform because more people were exposed to the debates, and we're all over really overwhelmingly supportive of, hey, here's a guy that doesn't understand this. And that's what I was looking for. Now, there's a few Hovindites that still support him, but nobody said, Hovind made a good argument. I think I'm going to switch from my position from being somebody who accepts evolutionary theory, Big Bang cosmology, and I'm going to go the Hovind approach. Nobody did that.
Yeah.
Right? So,
well, I mean, but then you look at the situation like with Bill Nye and Ken Ham, that completely backfired on Bill.
I did. I
And,
was not a big fan of that debate. I think Bill did. Yeah, I don't think he did.
They needed somebody with bigger guns. Bill's entirely too nice to handle a debate like that.
I agree.
He needed to have an army of scientists behind him, supporting him in that regard.
Yes.
That sometimes nice works better, because when you've got the obnoxious, person, the obnoxious, arrogant, scientists, and I don't mean that they are obnoxious and arrogant, but what I mean is it's a perception thing. Are you going to convince someone by being obnoxious and arrogant, or sounding obnoxious and arrogant, or are you going to convince someone by being nice and just thoughtful and trying to explain things the best way possible?
I agree with you. I agree with you, and that's my approach. That's why I'm not inherently, a tack dog on anybody who approaches me and on any of my science communicator accounts, because having been a person that's had to teach evolution to the culturally resistant because of religious purposes, they have their own, and having to deal with that, and that we're just adamant fans of Ken Ham and those sorts, you're not going to get anywhere if you go in guns blazing. So yes, it's important to be approachable. It's important to be likable. It's important to understand that their beliefs are important to them, and you have to respect that. If you don't respect that, you're not going to get anywhere with them, and they're just going to write you off as being a jerk. So I agree with that, but Bill needed to have more evidence. And what I mean by more evidence was a substantial amount of other scientists stepping up to reinforce his perspective.
I think Neil deGrasse Tyson would have been a much better choice for that.
Well, Neil he's a bit rough. When I say rough, I mean he would have ripped.
He would have ripped
Ken.
Yeah,
he would have ripped Ken. I agree with that.
I would have not picked Bill Nye for that debate. There's 1,000 other people that I would have known would have been a hell of a better job. Look, hell, even Bill Ludlow would have done better. Because he killed Hovind in that debate, just annihilated him.
Well, I have to run now, guys, because I have dinner I'm going to make. So it's, I'm not Monty Python.
Run away. Now, we're going to be ending this soon. I like to keep my videos between 2 and 3 hours, so we're going to be ending soon. We'll probably close it up. But yeah, I know we didn't really get too much on this particular topic, unfortunately. I know Joe really wanted to talk about Pilot Wave. We're going to have to actually do probably a presentation on it, because it's hard to describe Pilot Wave. I understand the concept of it. I do understand that these are matter waves that actually are almost like standing waves that basically show where the particle is going to go, rather than the particle itself being the wave function. And the problem I have with that is it's not parsimonious. And the worst thing about it is it produces a deterministic system. If you accept pilot wave theory, you have to accept hard determinism, and I'm not willing to do that yet. So, but that might be that too. That gets into the more, when Casey and I were talking about philosophies, this is what we meant. If you accept hard determinism, that's a philosophical approach, right? So,
well, you guys have an awesome night. I'm going to go and make me some food.
You too.
All right,
thanks for coming.
And by the way, I just followed you on Twitter, by the way.
Yeah,
I'll
put after this uploads, I'll put your link to your Twitter and to your YouTube channel.
My YouTube, because I'm so fancy now, I can stream on Periscope and YouTube at the same time, which saves me so much.
How many subs you got now?
How many what?
Subs.
I think it's maybe 272 or something. So
We gotta get.
It's
You're not
not-
hit 1,000 yet.
no,
gotta check
I'm not.
Oh my god, we gotta do that. You are so underwatched. That's not cool. All right, so that's the goal. We're gonna have to get you up there. And by the way,
Thanks,
as you know, we
guys.
are starting a new podcast. We have so many things in the works for this. Matter of fact, we have our domain. We have a call-in number. Even we're going high tech. We're getting some pretty famous people, big names, not just in like the great debate community sense, but I mean actual actors and models and things of that nature. So we're going to go big time, and we're going to be one of the segments we're going to have is promoting channels like yours and having you.
Oh, yay.
So
I will be happy to jump on, and I am looking for people for my audio podcast. It's hashtag Hey Scientist Mel is my audio podcast.
Who do you go with, just out of curiosity?
I host my own podcast, but it's on iTunes. I did submit it to Spotify. But if you go on any particular podcast app, you should be able to find me. It is literally hashtag Hey Scientist Mel, all together.
And there you go. All right, thanks, Mel. Appreciate it. We'll get you promoted. I really want to promote some of the other channels because we're being promoted. Other channels are being promoted. In fact, this Friday I'm going to be a guest on none other than the Holy Kool-Aid channel. It's going to be him and I having a conversation that he wanted to have, and he really wants to promote the GDC, and he wants to promote my channel, and I'm going to return the favor by having him on when we do the podcast. And I really like Holy Kool-Aid stuff, so he's got like 30,000 subs, so that's going to be huge. I'm really stoked about that. Nice guy, really nice guy, by the way.
Awesome.
You know Thomas pretty well, right?
I don't know about Thomas. I talk to so many people. I probably know like 25.
You remember me after you leave? Do you like go Steve who?
Like, who's there? Some guy named Steve that I'm supposed to do something with today. Oh crap! I'm in the woods. I to go back. I think that's literally what happened.
Yeah, I've had that happen with a few people. I was actually supposed to do something with Zoe on Wednesday, and that didn't come to fruition. But whatever.
That was unintentional.
No, it's okay. It's okay. Thanks, Mel.
All right, bye guys.
Bye. Somebody had mentioned in the live chat, and it went by, and I just kind of caught it, that I never mentioned Nolan and Hovind, and that's funny because I just literally yesterday said that Hovind had won one debate so far, and that was with Nolan. Hovind did a better job than Nolan did. I think Nolan sucked. And then I have somebody in the live chat going, "Oh, Steve never mentions Nolan and Hovind." Well, yeah, I did just yesterday. So it's so wrong. Some of these people, they just get so much crap wrong. I just amazed.
I had an amusing one on the GDB Great Debate thing, where I had someone telling me I was a liar because I was interpreting history in a way they didn't like.
You're interpreting history, which is fine. That makes you a liar.
Well, what it was, I basically said that you know, with this whole stuff with Trump recognizing, you know, Jerusalem as the capital. Right. Sorry.
Yeah. Mm-hmm.
Yeah. So, you know, I basically said that the only real reason that, you know, Israel as a country existed was because after World War II, you know, Jewish people didn't want to live in Europe anymore. You can imagine why. And so they, you know, and a lot wanted to go to America and create a better life. And unfortunately, America had this really hard-lined immigration policy from 1924, which, you know, which was on the back of the eugenics stuff. So it's like, yeah, we don't want black people and Asian people and Jewish people. We want white Western European people, except Irish. No Irish. We don't like those either. So, you know, they tried to curtail them, and effectively, you know, America had a sort of semi-official policy. I say semi-official as in, you know, it was, you know, still on the end of World War II stuff. And Truman had to literally sign executive order to try and allow more Jewish people in because they were turning them away. They had you know, it was something like, you know, 1 in 10 of the amount that should have been allowed in were being allowed in. It was really, really awful. And so the the policy was kind of, well, we've got a lot of sympathy for what you've went through, but don't come here. Go to Palestine. And the British, who had the mandate for Palestine at the time, they were trying to control the numbers, because what happened is you had a flood of people coming in, Jewish people coming in. The Zionist movement was very active. They were effectively picking up on the sympathy and using that. And so, the British tried to reduce the numbers going into Palestine, simply because it was creating ethnic tensions between two groups. And you ended up with people being assaulted and then murdered, and then there were reprisals and counter reprisals and counter reprisals, and it was just getting out of hand. And in the end, the British basically went, screw this, we're out of here. And then, the people basically had no other choice but to have a war. That was effectively the way I was going with it. And I had this guy saying, "Oh, you hate America and you hate Jews." And it's like, hang on. I was saying that the policy against Americans, and it was largely South America, the Alabama kind of areas, things like that. The white supremacist people who've been lynching black people, and stuff like that. It was those kind of people and the senators that they were voting for that were having these making these kind of arguments, in the Senate. And like I say, when you have President Truman, who's having to write an executive order to allow more Jewish people to come in because they were effectively being turned away.
No, I don't think I have a problem with anything you're saying. And I'm not sure how that translates to you being a liar, though.
Well, this is the problem. As far I was spreading libtard propaganda and Muslim propaganda.
Probably what you're saying actually probably what happened, but I don't.
Yeah. I was describing what happened from a perspective that he didn't like. And so as a result, I was a liar. And I had to point out, I tried to explain to him in kind of childish, in a way that even a child would understand, that lying is when you say something that isn't true. I believe what I say to be true, and I have, evidence to support it. And I've presented the evidence to support it.
How do you get different opinions on lying? Well, the Clark posse gets that confused a lot. They think that because we have different opinions, we're lying. And when I get, Ronnie, like he had a little sad today, and I think somebody recorded it and put it on the archive channel. Pretty sure. But I watched a little bit of it, not the whole thing, but I watched a little bit at the beginning because I took a screenshot. There's like 6 people watching. And, he's like, oh, well, everybody in the great debate community knows Steve lies. And Philo Blues is like, what has Steve lied about? And just like earlier, Sean Hufford was having a discussion, and I was watching the tail end of it, and you have Kaiser Crew going, oh, Steve's a lying shit. And Chris is like, what did Steve lie about? And that's the question you have to ask people. What is being lied about? As Clifford said, look, having a different opinion on something is not a freaking lie. I differ in my opinion. Matter of fact, I differ more than just my opinion. I think the science is fundamentally conclusive that these people are wrong. It's not an opinion. The science shows you people are wrong, period. But that doesn't make me a liar. And so when they throw out these things like, oh, look, even some of the members of the GDC thinks Steve's a liar. Okay, well, maybe it might be a handful, but you know what? Show me what I've lied about. Same thing with Cliff. What has he lied about if he has a different opinion? And by the way, I think he's probably right about the history content. But that's still his interpretation of what happened. There's no way you can construe that to be a lie when you're just giving your opinion on something.
Well, like I say, giving my opinion with evidence to support my claim. And I had to try to explain to this person that unlike something like mathematics, where it's very black and white, the answer is either correct or not, with, humanities such as, history, it's not black and white situation. There's an awful lot of gray area. And once you realize there's gray area, you can effectively, in a way, this is how you get revisionist history, that people look at it from a different viewpoint,
sure,
and they can come to a different conclusion. I'll give you a simple example. There is a great schism in people who study Nazism, whether Hitler was the master of the Third Reich or a weak dictator. And you can use evidence that's available to support both claims. you've got him writing the stuff and trying to run, run the war, when Russia, the Russia campaign up Barbarossa was failing, things like that. And he's signing all these bits of paper. But then there's also evidence to say that, after he won the election, he used to sit up in the Beige Garden, watching movies until 1 o'clock in the morning, giving his subordinates, a little bit of his attention. They were clamoring over each other to get his attention. He'd give vague orders, and then they would carry out orders on behalf of the Führer. So they were doing the work. He was giving vague ideas of what he wanted.
Arguments to make. I think you could make obviously, I think one way or the other. I think he was a horrible dictator. But I mean, if some people wanted to argue the opposite, that he's like a weak leader, and that other people were kind of the people in charge, those are things that are valid to discuss. I think, are they not?
Well, yeah, but what I'm trying to say is that, there is evidence to support both sides. It's not a black and white situation. He was a dictator and he ran everything and made it work in his image, But they you could say the same thing. I'm not comparing him with Trump, but Hitler with Trump. But I'm saying, how do you look at Donald Trump? Is he running the thing, or is he led by his emotions, depending on what he saw on the TV today?
I think he has handlers at this point. I think they basically said, okay, this guy doesn't know what the hell he's doing. Let's see if we can at least get something accomplished. He's just a figurehead at this point. He doesn't do anything. Like I said, I was the first person to say,
I don't think what I asked actually needs an answer. I'm saying that you can effectively come to two different conclusions, right, and use evidence to support which one you think is.
Neither one's lying. Neither side is lying when it comes to those types of things, Cliff. But again, you understand this, and I understand this, and I think most people do. Certain people love a black and white thing. They fall all the time in the black and white fallacy. They don't understand concepts like nuance. They simply don't. And that extends into their scientific approach as well, because that's why they don't understand science. They don't grasp that a lot of this stuff is very nuanced arguments.
Well, I mean, there were a couple of people. Another person, because I said that, the two real reasons why America loves Israel is, number one, because the religious fundamentalists think that if effectively they'll fulfill the Bible prophecy by having Israel as the promised land for his people, for God's people, and then Jesus will come back with Armageddon. That's one part. And the other part is that, they have a very strong defense, industry. Not industry. They have a strong defense spending, and America makes most of their guns and bombs and planes. So, it's like, it's good for American jobs.
Well, sadly, that's true, though.
Yeah.
That is true. I mean,
I said this.
You can't sugarcoat that. War is profitable.
Yeah. And I said this, and then someone said about how, the Muslim nations have more of their spending. And I said, yeah, but the problem is you're actually looking at current trends, because there's an arms race going on in the Middle East region right now, where you have most of the military, most of the states, they spent a lot of money in, the 80s and 90s, and then they didn't really spend much. And now that you've got ISIS and insurgencies going on in that part of the world, they're basically thinking, we don't want to be the next, 1979 Iran, and end up, having our kingdom taken over by some, religious caliphate type thing. So we better make sure that we're well armed. And so they're buying stuff from America and Britain and France, and there's been a massive increase in military spending.
Well,
and I said, so, this evidence that you're looking at there, that's reflected by, there's this increase of spending right now. And they said, no, it isn't. And so I went through the list, and I just created a whole list of all the Middle East nations. And I said, sort of Kuwait, Qatar, etc., etc. In fact, today, which has been fantastic news for me, one of those countries, Qatar, I think it was, has signed for Eurofighters, Typhoons. My dad is on the export team for the Eurofighter Typhoon. So that's kept my dad in work for another couple of years.
But let me, I have to end this. We reached our 3 hours, and I've got so many hangouts I've got to catch up on. I promised Geo Straber I'd listen to his discussion with Anthony Riley. It's 3 hours long. I'm not watching 3 hours, but I'll watch maybe the first hour, maybe two. I also have another interview going on right now with Shannon Q that I want to listen to. But if you guys want to continue this, you're more than welcome to start a hangout on the GDC and talk politics. Cliff, if you find anybody to join you, be my guest. I think you're a manager, aren't you, of the channel, Cliff?
No, I don't think I'm a manager, but you know.
Do you want to be?
I'm not. I don't really go that much, to be honest.
Okay.
I mean, you can't if you like, but
we have 20 managers of the channel, so somebody might be listening and want to start a hangout on the GDC channel, which is fine. To continue on what Cliff's talking about, I have to end this. So.
And Steve, please update us if you decide to change your mind after watching that Anthony video.
Yeah, no, and I promised Gio and I would. I keep my word. The problem I'm running into now, and I hope Gio understands and Sean Huffers understands, is that after Tommy posted what he posted, it's going to be much harder to change my opinion now. And I understand Anthony is like 80 points ahead, but I can tell you right now, we can make that up pretty quick. I have no doubt we can make that up pretty quick. And if I really push for Tommy, he has a pretty good chance of winning. But I haven't made the decision yet of what I'm really going to throw, my weight behind and ask everybody to do. Not that everybody listens to me, but I think we could, I at least have enough connections where I could probably pull out another 100 votes.
Well, Sean is threatening to make you a 2018 nominee, Steve, and he's pledging to get you into the.
Of course, he can make me a nominee. Anybody be nominated, but I don't think that is really going to fly, because then you'd have to nominate Reds too, because Reds is pushing Tommy right now.
Can I just point out, as someone that doesn't really care that much who wins, for me it's just a bit of a lols fest. It's like, sure. These are people that have said some really silly things this year, and usually it's towards the end of the year the stupid things come out more. So Tommy's going to be getting it because he's obviously being the noisy one. If it was C. Brown, being
Brown was in 10th place. He was in the worst place.
He'd be up there as well. So effectively, it usually ends up the person who's saying the silliest things at the end of the year tend to be the ones that are being going to vote.
Anthony Riley, we all know, is dumb. He says dumb things. Nobody's disputing that. But my position right now is Tommy's dumb effery, because again, I'm trying not to demonetize this video right off the bat. Is just unparalleled. I mean, yeah, we expect dumb stuff from flat earthers. Anthony Riley's stupid. His idiocy is unparalleled among flat earthers, probably. But I think Tommy is still worse because he says things that are just outright dangerous, and I think that needs to be considered in.
I think I would agree that. I mean, I voted already, and I did vote for Tommy Hall as well as some other people. I'm not going to use alt accounts and stuff like that to make it move in any other direction. I just voted for people, and that was that.
We might have to have a hangout where I'll have two people advocate. One person will advocate for Anthony, one person for Tommy, and we'll just fight it out. I'm okay with that. But I have to say though, this is for entertainment, and Ronnie and his amount of butthurt and crying over all this is just obscene, because there's no bullying, there's no harassment. This is people saying stuff that we are opining on. We are saying this is stupid, and we're allowed to do that, okay? Because you're putting it out there on the internet. We are mocking it. We're allowed to do that. You say dumb stuff, we can say you're saying dumb stuff, and we can make light of that. That is perfectly within terms of service. Matter of fact, how do you think YouTube got started? It was people making response videos to people saying stupid stuff, right? So,
I agree with out there. I agree with you on Tommy though about it's dangerous because what's the worst thing that happens if someone says something about the Earth being flat? Is that going to make any real difference to anybody's life?
Right. That's kind of the way I'm looking. Plus, his arrogance on it. Tommy's just so arrogant lately, and now what's worse is he's got into persecution porn on it, and basically going, oh well, they're picking on me, and they're making me feel bad because I'm saying these things, and they don't want the opposition being heard. And I'm like, oh, that's just dumb. That right there alone should win you the dumb thing of the year. And I know Red's is going to kill me for that, but I'm trying to see if I get one video that's not demonetized. My last 4 were demonetized, so.
The amusing thing about it is, there's a simple answer, Tommy. If you don't like being laughed at, stop saying silly things.
Thank you. I said the same thing to them too. I even said, Tommy, look it. I reached out to him. I said, Tommy, if you were to stop saying these things that you know are going to get you flack for it, you know people are going to jump on this, you know people are going to try to correct you. If you stop saying those things and you actually said something that was correct, you wouldn't be in the running. And matter of fact, I said exactly what Red was going to say. Red said, hey, you know what? You need time away. You take a month, which I think is not long enough, but you take a month and you take care of whatever the stuff you're going through. I understand everybody goes through stuff. All of us do.
Yeah.
And if it affects you, because some of this stuff can get to you sometimes. Let's not kid ourselves. No matter how thick skin you get, every so often some things get to you. I mean, Ronnie never lets me forget the time I asked him to take down a video, which, by the way, he said, oh, I was embarrassed, and that's why I haven't taken down the video. No, there was no embarrassment whatsoever. The reason I asked him to take down a video because he was fundamentally wrong in what he said, right? He was asking people to go to my Patreon for the wrong reason, right? And he was saying things that I have never said, and I was like, this is misinformation. Take it down. That's the reason why I asked him to take it down. I don't want people to support me for the wrong reason. I'm very much in that mindset where if people want to support me, it's for the reasons why I'm putting this out there, right? I want them to Patreon for the right reasons. I have an ethical consideration. I'm really pro ethics, right? Ronnie doesn't get that. He has no ethical considerations. He don't care about anything. I don't think he knows what ethics is. I don't think he has an understanding what it's like to be ethical or honorable. He lies through his teeth, and we can show that he lies through his teeth. If he wants to say that we're lying, great. Show us where we have. He has yet to do so. Matter of fact, every video that he's had saying that we have lied only backfired and showed that he was in the wrong again. Every single time. G-Man does the same thing.
It's projection most of the time, I see.
Absolutely projection. You know, he has lied countless times. Oh, my God, has he lied? We have a whole document on transcripts of his videos that you can go back and see where he says one thing, and then in another video, absolutely 180%, change. Just completely
the funny
opposite.
thing is, most of this year, there's been a whole show every week about it, and it's called TST.
They point it out all the time. Yeah,
every week is here's what Ronnie said this week.
And he says, oh, I never said that. Oh, here's the transcript. You're saying it. I have a video. I have videos on this saying, Ronnie, you say you never said this. Well, here it is. You saying it.
I have a video on my channel.
Well,
I don't
Trump didn't say that.
Yeah, I'm allowed. But here's the difference. People in the live feed, somebody saying, oh, Steve, was talking about people lying. Now listen to him. I can call somebody a liar and I will back it up. I will show where they lied. And I've done it in videos. I dare anybody to show a single place where I've lied in this community. One time. Just once. Because you know how many people have taken me up on that offer? 0. And matter of fact, I can tell you right now, most of the people, if not almost all the people at GDC that I associate with, I can't think of any of them when they lied. I can't remember any time anybody in the GDC really has lied. There's been a couple cases of questionable things, but no lying. I think most people are honest in their position, right? And that's what a lie is. Are you honest in your position?
I think there have been times where people have dug their heels in and then they've later said, yeah, actually, maybe I was being a bit douchey.
But that's not, I don't know if I want to go down the route of calling that lying. I think there's
I think that it's the element of personal dishonesty sometimes, but I think the problem is that personal dishonesty is kind of hidden in your ego and your mood at the time. And sometimes you take a step back and say, yeah, okay, maybe I was wrong there. And, it's not so much, it's not that someone knows that they were telling the untruth. It's that they allowed their feelings to run away with it.
Right.
I'll give you a good example. We had that disagreement, a year ago now?
Yeah.
I was quite bitter at the time. We got over it.
Yeah.
But,
totally.
it just, there was an awful lot of digging of heels in.
But they don't seem to understand that. People do get past things. When you work out something, you're like, okay, this is what happened. Let's, kind of recap it. Okay, it's done. It's over. They don't see that. In fact, you can tell right now, Cliff, they're still trying to drive a wedge in some ways. Because they're bringing that up too. And it's just like, Cliff and I have no beef. 0. Like literally 0 beef. I have the utmost respect for Cliff. I always have. I like what he has to add to the hangouts. But they're still trying to go, oh, look, even Cliff's calling Steve a liar. No, he's not.
No. Well, so is that being said now?
Yeah, yeah, it gets brought up
No.
every so often. I'm not, no, dude. They love to bring up old stuff.
Oh,
But sure.
gosh.
Just
This
today,
is something
he brought it up.
else.
Well, he
Okay,
didn't specifically, but he's like,
anybody, I'm not going to go into the details of it, but basically, Steve got the wrong impression of something, and he was effectively going off that wrong impression. And because he had the wrong impression, his view was distorted by that. You know, I'll give you. I actually had to use this in that, that thread I did with someone saying I was lying, and I had to explain what lying was. And I used this analogy. I said, imagine I've got an apple on a desk, and I leave the room, and I come back, and I see Steve eating my apple, and I say, "You stole my apple." And what Steve said is, "No, I bought this apple from home, but I saw a guy a couple of minutes ago walk out with an apple in his hand." Now when I said you stole my apple, I believed I was telling the truth. I believed he had stolen my apple because there was an apple. Steve's eating an apple.
Now what happens if I have the receipt in my hand?
The conclusion was wrong, but when I thought it, I thought I was telling the truth at the time.
Right,
now,
and I
because the truth was not the truth that I thought it was, doesn't mean to say I was lying.
That's why I've never said people are lying when I know they're not lying. I honestly, thanks, Joe. We'll catch up with you, buddy. We're going to go more on the nuclear stuff later because I actually realizing that I like talking about it. But yeah, I've never said Cliff was ever lying on anything. If I go back and look at anything, I've never said people are lying except when I can demonstrate that they're lying.
Yeah.
And
no, I did actually say you were lying.
You did. Yeah, no, you called me a liar, but I never did you because I knew there was some talking past each other. I knew there was some mistakes being made, and I was not going to say that you were lying because I knew that you believed what you believed.
Yeah.
That's not lying, right?
Now, what happened was
fabricating shit.
So what happened was we basically, we talked to each other instead of past each other, and we came to a resolution about it.
But
I made a retraction. I said, look, hey, said this thing. It's not true. I've changed my position.
But they can't do that, Cliff. They're incapable of doing that, and that's why when people call me a liar, I want them to come forth, man up, get some balls, and show the evidence. And I'm fine if somebody says, "Look, I called you a liar. I was wrong." I don't ever bring it up again. But here's the funniest thing: I see people all the time doing that. I'll tell you today. I just saw literally Kaiser Cube just the other day said, "Hey Steve, if you have a hang on this, unblock me." And I was thinking, okay, maybe he wants to apologize. Right? Maybe he wants to, stop accusing me of lying all the fucking time. Oop, there goes my monetization. But no, I saw him on Sean Huffer's live chat going, "Oh, Steve's always lying, and Steve's a lying sack of shit." And Chris said, "Well, what is he lying about?" He's like, "Well, come into a hangout with me or Skype me, and I'll show you." And Chris is like, "No, you know what? I'm not interested," because he's just. There's no possible way he has evidence that I've lied because I haven't lied, and I think people are tired of that. And look at if you call somebody a liar, you need to back it up. I will back up that Ronnie has lied. Absolutely back it up. You give me the time, I will show you in depth. And matter of fact, how do you think people like Odeon came over to our side? Right? Right? I showed him the evidence. He's like, "Oh crap, yeah, Ronnie's full of crap."
Now, I mean, one of the things that I think is a problem in this community is that it's mostly guys. And, effectively, there are kind of a couple of types of people. There are the brawny type of people, so they want to beat people up by punching them and things like that. They think with their fists, that kind of a thing. But this community tends to be full of people that effectively fight with their mouth, with their mouths, stroke text. They're fighting with their brains. So it's basically, typing egos at dawn, at noon.
Yeah,
and
no,
so
that sure.
And so effectively, it's a kind of like cerebral fighting.
But Cliff, here's the thing.
Well, hang on, I just want to finish off the thought.
Go ahead.
For me, maybe it's I think it's an Aspie thing, but I don't know. Maybe it is, maybe it isn't. I don't really suffer the ego thing. If I'm wrong about something, I'm wrong. I don't really feel the need to, a perfect example, I had a disagreement with Rumpus a few weeks ago, where, I said that the Treaty of Versailles was signed in the same coach as the Germans had been forced to sign, the surrender. And it wasn't the Treaty of Versailles at all. We had a bit of a row short time on TST. And, after, I did a bit of typing and I said, no, you're right. And what I'd done is I confused the French surrender to the Germans in 1939 with the Treaty of Versailles. It was a verbal typo. And that was that. That was done with. Now, other people might dig their heels in and say, oh, well, and they'll make excuses why they were wrong or something. Well, I have an excuse why I was wrong. I I remembered the wrong thing. I mean, talking about something that I learned like 18 years ago. But, it's like something that popped into my head and I just got a little bit of the details wrong. The general thing was correct. But anyway, what I'm trying to say is that, that I'm not afraid to be wrong about something. If I'm wrong, I'm wrong.
Yeah, well, the same way. And in fact, Rumpus and I had a very, very minor thing. It wasn't even, I wouldn't even call it a disagreement. I even said I might be totally wrong on this. This is how I remember it. But yeah, you know what? There's a good chance I might be wrong on this. I didn't dig it at all. And Rumpus explained it. And I'm like, after a while, I'm like, yeah, you're right. You're right, Rumpus. I mean, at this point, I can't even come up with a reason why you're wrong. I fully agree with you on this. And that's how it's supposed to work. That's how any science works. No two scientists are going to think the exact same thing, or in science, you have differing opinions, right? Not everybody's always right, no matter what you think in science, right? Whoever presents a better case, he presented a better case. However, I still think he's wrong when it comes to like something when he's talking about rejection of a proposition. I think I go with MP and Bernie on this. I think they present a better case, right? I don't think what Rumpus is saying makes sense, but it is. I mean, he's dug in his heels on it. Fine, maybe he is right, but I don't think so. But some people like him, he won't admit. I don't think Rumpus will admit that he's wrong, even if he is. He's just not that kind of personality type, right? But I mean, I admit it. Thank you, RSC. We'll catch you later, buddy. Like for example, the whole sublimation thing. Yeah, I was wrong on that. Hogtie was right. Fine, he presented a case. I listened. He was right. But on the Coriolis effect, people presented a case to him. Hogtie was wrong. Okay, so what? Big deal. But what happens is that it's like people like Ronnie and them. They think that any sign of admission of being wrong is a sign of weakness, and that it just obliterates their entire theological framework. And I don't get that at all, right?
Yeah. Yeah, like I say, the problem is that because this is a community of largely blokes with lots of testosterone going, and effectively people are having fights with their brains. They're putting their ego on the line to be right.
And can I point something out before I end this real quick?
Yeah, sure. Well, I just want to say that some people can take it being wrong, and other people can't.
But let me show, you're right. But let me show you the mindset of some people. Like for example, GPH, our favorite fundy in the live chat, says Steve lied when he says there wasn't Christian bashing in his chats, but later said Blue was banned for a while he was Christian bashing. What they don't understand is nuances. When I say there's not Christian bashing allowed in my chats, meaning that it doesn't happen because I ban them when they do. They don't seem to understand what that means. I don't allow Christian bashing in my hangouts or my chats. So when someone does start to do that, they get banned. This is one of the reasons. Well, I didn't ban Blue from the community, but that was somebody else. I banned him from my chats. But they don't understand the nuance then. When I say there's not Christian bashing in my chats, that means I don't allow it. There's a subtle implied thing in that context, meaning that I don't allow it in my chats when I say it doesn't happen, because those people get banned. But certain people don't understand how English works. They don't understand things that are implied. It's really strange that the English language goes above their head when you start explaining to a normal person. And I don't mean disrespectful for people that are on the spectrum, because there's some problems with the social cues. But for most people, and I hate using the word normal there, my apologies. But for most people, they do understand context. When I say, hey, this doesn't happen in my live chat because I put a kibosh on it. It doesn't mean that a person's not going to come by in the live chat and go, oh, Christian sucks. Okay, I have no control over that, right? But that doesn't make me a liar for saying that. It just means that somebody didn't understand what the point of that what I was saying was, right? So there was no lying on my behalf on that.
Well, I mean, this is a problem with, you know, effectively language in the first place. You said it was language, but effectively, you know, when we communicate with each other, when we type something or say something, we're trying to get a message. I'm trying to get a thought from my head into your head and be able to get it in a way that you understand.
Yeah, you don't have time to expand upon everything, right?
No. I mean, I had a problem a few weeks ago on Twitter where in the UK, cyclists are treated like shit. And I said a quote. I said something, and I said, you know, if you read the comments under a cycling video, just read any of these comments. I posted a link to it, and I said, if you change the word cyclist for black, you can see the discrimination. And people went mental that you can't compare being a cyclist to being black.
Oh no, I've done that before. You're right on that. I've changed words and said, look how this sounds if you change one word.
Cyclists weren't made to work in fields for free. It's like,
no,
oh,
they don't understand what you're trying to say on that. I've done that, Cliff. I know exactly what you're talking about. And this is what I'm saying. They don't understand the point being made. But I think certain people like GPH and the Fundies and the Clowncore Posse, they take things so hyper literally that they don't understand nuance. They don't understand.
The problem is they get fixated on one point. In this case, they got so fixated on the word black that everything else before and after it just became fuzzy and didn't mean anything.
It was irrelevant at that point, yeah.
You know, they just got locked on it, you know.
Yep, I agree.
It's not, you could put any version of discrimination in and it would still be discrimination.
Yep.
You know. But
I agree. I've done that. Like I said, I've read something and I said, dude, change this to some other thing and look how bad it sounds, right?
Yeah.
So
yeah.
But anyways, I got to get going on this, so I got some other stuff to do. So Cliff, thanks for dropping by. Midnight, thank you. Live chat, thank you. And like I said, look at if anybody wants us to believe Ronnie that I've lied, by all means. The only thing I've ever asked is show me where. Prove it.
Show me
I mean, I will be happy to give you the time of day and come in here. And to date, I have not had a single person take me up on it. You know, and that goes to anybody. That goes to anybody in the GDC. I used to have, remember back, I had Steve's Court, which by the way was fun, and people want me to do it again. But you know what? I will give people, in fact, one of the situations we're having real quick before I end this is that somebody, as we all know, from the GDC porn bombed. Now, if you say that person was removed from the GDC. That person does seem to have some sense of remorse, but not to the point yet I'm willing to even entertain, you know, taking them back. And that saddens me because I really like what this person had to add to the great debate community. But I have to enforce the rules, right? I have to enforce some kind of standard. And so if somebody like that would say, look, I really regret what I did. I apologize to Neffy. And, you know, they have a timeout for whatever, how many months or a year or whatever, and they want to come back. I am that kind of person to say, okay, let's give them a second chance kind of stuff. I have with a lot of people. I'm very forgiving, trust me. But when somebody says, oh, Steve, you're a liar, and then they say, oh, well, I take that back, and, you know, I apologize, and then the next day they say, oh, Steve, you're a liar. Yeah, I'm really not going to give them much time of the day. It's just not going to happen. But if somebody really wants to come in here and make a case, I'm okay with that. But anyways, I got something else I want to watch. So guys, thank you very much. I'm going to give the last word to Cliff, random person. Take it away. Don't say something against me, Demond.
Just think about what you say. There you go. Think about what you say. Think about how it's received.
Perfect. Thank you guys for watching. Later.